So, due to the nature of the application we're building today, we will be using Firebase and testing, writing tests. Because of where I'm doing test-driven development, writing tests for Firebase for a project that uses a Firebase server is slightly different from writing tests for projects that use normal REST APIs, right? And I know most of you might be working with REST APIs. So in order to cover all of everything, right, I will first of all, before going to the main application, create a little application. We will create a little application using a fake HTTP server, a fake HTTP REST API, and then build a very short, just a one feature application around it. All right. So basically, with clean architecture, it's usually gonna be too much work anyways if your application is very little. So if you've maybe got only one or two features, you don't plan on expanding the application later on, then clean architecture might be too much, just it might be overkill for your application. But if your application is going to be industry standard, if it's going to production, if it's going to be a huge thing, right? It's not maybe just a little personal project that you're building, then yes, go ahead, use clean architecture. So for that reason, I'm going to create a little. For that reason, I'm going to create a little Flutter project. Next, ddd tutorial com.besttech. We're going to start off with an empty project. DDD tutorial, yes, create project offline, and then we create our project. The project started now. Let's go ahead. I'm going to go to mockapi.io. You can visit that. Mockapi.io, or you could just follow along the endpoints that they are going to create for me, or should work for you as well. So I'm not going to take down the endpoint or shut down the server. But then preferably, I think you should just do the same thing with me. It should be, we just have to do a few steps. So go to mockapi.io, log in, right? Once you log in, you can log in with a Google account. It should bring you in here with the project. We can start by creating a new project. Right, so let's go ahead and add a new project. I'm going to call this DDD tutorial API prefix. Let's just go with test API, right? So by name, we can create our API. That's done. So let's go ahead and add a new resource. For this, we're going to add users. So we're just going to simulate a simple login, or no, a simple, let's see, creating a user and fetching the user. Should we do users? No, do something different. Yeah, let's just do users. Let's just create and fetch the users. So this is the schema. It has an ID, created that, name and avatar. Yeah. I think this is enough. And we can see over here, we can do a get request. So when we're requesting for a particular user, we can do users / the user's ID. And when we want to create a user, we can post / users. So these are the two endpoints we'll be using. We'll be creating a user and also be fetching our user and displaying our user. Or no, let's fetch all users and display all users on the screen or something. So let's go ahead and do that then. So let's go ahead and hit create. This should create it for us. So you can actually drag this to generate fake users. So if I drag this, it will generate fake users for me, but I don't want that yet. I want us to be able to create the users ourselves from our Flutter application. So let's go ahead and get started. So in our Flutter application, first things first is to create our layers, right? So inside of our lib folder, usually I personally create maybe a directory called src, right, source. You can call it, you can use features because basically the features will be in here. So our application, when you get an application, you have to split it into different features, right? So for example, we have the authentication feature, we could have the chat feature, we can have the hosts feature or something like that. We just break them down into different features. I spoke more on this in the video that I referenced at the beginning. The video link will be in the description. We'll also put up on the screen as well. So let's go ahead and create our features, right? Or you can create source, right? As almost every public project does. So inside the source, we start by creating our first layer, new directory. Let's create our first feature will be the authentication feature, right? Inside of the authentication feature, we're going to create a new direct file. I'm just going to do this at once so I don't have to waste time creating all the layers. So remember that we always start from the domain layer, right? So this is what we're basically going to do. We're going to create a user and then fetch every user that we've created and display them in the UI. So on tap of a button, we can add a new user and so on and so forth. All right, so let's go ahead and add the domain layer. So in the domain layer, we will have our entities, right? In our entities, we will have the user data. So we have the user entity. So let's go ahead and see what our user has. So let's try and create a new resource. So you can see that a user has ID, created that, the name and the avatar. And these, I think these will come in the same format when we're fetching them. So ID created that, name and avatar. Right, so we will have the class user. And the class user will have I think the ID is an integer. So because I think they're using an SQL database, so yeah, it should be an integer. So integer ID, we have final string created at. I think it's a string because I mean it looks like, I know it's a string. So name. Let's go ahead and also add the final string name. And finally final string avatar. Alright, so after that, let's create the constructor. In here, we will require this.id, required dot created that, required this dot. No. We can make this to be a date time object, but this is just for this is just a simple setup. So let's just keep it as a string instead of changing it to a date time. Let's just keep it that way. And then we finally have name and avatar. Right, so this is it. So this is set. But now there's an issue, right? So usually for test-driven development, even without test-driven development, we will need to be able to know when a user or equate users or equate our objects, right? So in Dart, generally Dart uses referential equality, right? So which means that when you check if a user, so if in here, if in my void main I had final user 1 as a user and I created ID this that right, and the ID, let me change that to 1, and I can do the same for user 2, right? If in Dart I said I wanted to check for this and say, do you know what, let's go over to dartpad and do this so that we can dartpad.dev boom void main In fact, let me copy this entire thingy. Right, so yes, so let me move this below. Format. Yeah, so if I went ahead and said print user1 equal to user2, because we know that this isn't equal, right? User1 isn't the same as user2, right? Because their IDs are different. I mean, everything else is the same. But let's go ahead and check that. You can see it says false. And what if we actually change something in here, right? So what if we changed user1, right, and checked, we change user2 to have the same data as user1, and we hit run, we can see it's true, right? Now that's all great because it's detecting that these two are the same, right? But then let's imagine, what if we had a different data type? So this actually works. The equation actually works for objects that have simple data types. For example, these they have an integer and strings, so there's nothing else, there's nothing complex. But what if we get something like, I don't know, what if we get something like a date time, right? So required this dot create that. Let's make that date time, right? And we create the same time, right? Final now will be date time dot now, and we in here use now, right? We make that final, replace it with final, and now we hit run. So now we can see this failing because we have something that's not really equatable in the, it's not a simple Dart data type, right? So in this case, what Dart will do, let's go ahead and find the operator class. Yes, so over here we can see that how the equality method or the equality operator works in our Flutter project will be that by default all objects will return true if and only if that the first and the second objects are the same object. So basically, how computers store stuff, right, is when we create this variable, it takes this, goes to the computer's memory, and then goes to an address, maybe, I don't know, maybe some address like this, and it saves it in there. It saves that value, this user, in there, right? So this variable name, whenever we take this variable name, we're basically saying, in turn, it actually stores the user's data. So it stores this, no, not that. It will store this in there, and then inside of this variable, it will store this address in there, the address's data in there. So whenever we do this, we're essentially giving Dart the address of this variable in the computer's memory. Alright, so that's, you can imagine it that way. So if that is the case, then whenever we do user1 equal to user2, we're basically checking if they are pointing to the same object in the memory. Alright, so in cases such as these where we have non-constant objects, it uses what we call referential equality, meaning that it checks if they're referring to the same object in the computer's memory. If they're not, it will return false, as you can see over here. In order to make it use something called value equality by checking its values, we can then override the equality operator in our Flutter class. I don't know if I'm making sense. So, like I said, this isn't going to be totally beginner friendly. You should already have some grasp of Flutter. Then this is what we're talking about, right? So these two objects, we have to be able to know if an object is the same based on their values, not based on their reference in the computer's memory. In order to do that, we can override the ball operator, right? It has the double equals, and it takes the other, right? So what this essentially means is whenever we call an object, any version of this object, for example, user1, and we add an double equal sign in front of it, and we put in another object on the right hand side of that equals operator. So in this case, user1, right, and we put in these right here, and then the other will be user2, right? This should return true if they're identical. So Dart has the identical function. It checks whether two object references are to the same object, right? So you can read through the documentation, but we can see here Dart values what is stored in variables or object references, right? So I told you what is stored inside of these variables are these references, the references to the objects, right? So let's go ahead and read. They can be multiple references to the same object. So even one object. So there could be cases where if we did user1 is equal to user1, and it could return us false. Wait, let me comment this out. And it could even still return us false because there's two different references to that same object. So there are cases like that. In this case, we don't have that here, right? So let me go ahead and change those out. Let's go back to reading what we were reading. So that could be the case. In this case, that's not the case because our case is pretty simple, right? So if an identical call returns true, it's guaranteed that there is no way to distinguish the two arguments. If it returns false, the arguments are not only known to not be the same object. Alright, so this is the default way that Dart does it, referential equality. So we are checking if the object on the left hand side is equal to the object on the right hand side, which is the other, right? If that is true, then return true, right? If that is not true, then we go ahead and check if the other is the same object, if they're the same type, right? So if the other is also a user, so we check if the other is user, all right? So this is the start of a different check. This is how value equality works, right? So this is referential equality, and then now we're moving on to, so we check if they're referentially equal, right? If they're not referentially equal, then we check, or are they value equal? So let's go ahead and start with value equality. So we check first of all if they're the same, if the other is the same as the same type as what we have, right? So if it's the user and the other the runtime type is equal to this dot runtime type, right? So if their runtime type is the same and other dot, let's use the ID. So in this case, what we're essentially saying is, right, check what is the problem, unnecessary disidentify it. So that's unnecessary. Yes. So what we're essentially saying is check if they're referring to the same object in the memory. If they're not, then go ahead and check if the second thingy, right, this is a user, right, which it is a user in this case, and also make sure that its runtime type is the same as my runtime type, the runtime type of the left value of the left operand. And then finally we check if their IDs are the same. So what this simply means is if all of these pass, return true if they have the same ID. So whether they have different names and different dates, so far as the ID is true, then it's the same person. All right, so we will see how that works. So now this also requires us to override the hash code. So after overriding this, you must override the hash code, right? So integer get hash code. You can go into the Flutter source code to see how they've done it. This is simply how they've done it, I think. So we can go ahead and say id.hashcode, right? So I'm using id.hashcode format. Yes, I'm using id.hashcode because the ID is the only thing that I'm using for an equation over here. All right, so over here now we can actually change this thingy to, I don't know, Deborah. We can change this to a Lee, right? And we can do run. And we can see it returns true, even though they've got different names. But so far as their IDs are the same, it will work. Right, so if we went ahead to also check if their names are the same, so we say don't only check if they're the same using their IDs, check if they're the same using their name as well. Right, so sorry. If name is equal to other name, you could also make it if other name is equal to name, whatever. I just prefer to have that convention is equal to my name, right? And then over here, I can also add, with this, we add the superscript symbol and we can say name.hashcode is the same as mine. And we can go ahead and do that. We can see it will return false this time because their names are not the same. So in order for two objects to be equal, for two user objects to be equal, we're essentially telling Dart to check if their IDs are the same and if their names are the same. If any of these are not the same, then please return false. Alright, so we can go ahead and keep adding whatever properties. So usually for server data, servers cannot have two different datas. They're usually unique datas. Alright, so if you know anything about SQL, you know if they're unique. If you don't have any idea what I'm talking about, you can watch the other video. We used an SQL database in there, and I explained a little bit, I think a little bit of what it means. You can read up on SQL database, but basically these IDs are automatically generated by the database, and they cannot be repeated, alright, because they're unique, always unique, alright. So these can never be the same. So usually I'd use only the ID to check for my value equality. So even if their dates were different, right? Even if we created the first user, say now, final tomorrow will be date time dot. Do we have a tomorrow? I don't think we have tomorrow, so I'm just going to use now dot add. Sorry, dot add. I'm going to add a constant duration. Does duration have days? No, it doesn't. It has hours, right? Come on, mate. Don't tell me you don't have days. Because I know you do. Let's say 24 hours. Yes, so tomorrow is 24 hours. So, right, so let's go ahead and say run. We can see that they will still be the same user. Even though they were created differently, they have different names. But then since their IDs are the same, this will be true. If we change this to 2, it would change. Right, so in our tests in our application itself, we will be checking the equality of these things over and over. Now we don't have to worry about writing these over and over, right? Defining this stuff over and over now in each class, right? So in order to make it easier, we already have a Flutter package called Equatable. Let's go over to pop.dev and we can search for the Equatable package. We can see that package over here, 2,000 likes. So it basically carries out all of, you can see, right, exactly what we've done, right? It carries out all of that for us, right? It does all of that for us implicitly. So all we have to do is pass it the list. We have to pass it a list of every property that we want to use for our value equality. Alright, so if we wanted to use ID, we will pass only ID in here. We override this props and we pass it in there. If we wanted to use ID and name, we will also pass in the ID and the name in there. Alright, so let's go ahead and also do that in here. Let's start by adding Flutter pub add equatable and Flutter pub get. If you're on VS Code, the Flutter pub get will be run automatically after you add a package because it listens to your prospect YAML whenever there's a change. All right, so let's go ahead and close this bit up. And in here, in order to use it, we can see in the documentation, you can go ahead and read this, but I'm just going to talk you through it. So in order to use that, we can make that class that we want to change to use value equation, equation, I don't know, right? We can change that class and make it extend the equator, but we can see it's screaming at us. It needs to overwrite something, the props. We can click on that to create it, remove the to do, and finally pass it the things we need to use for equation, in this case an ID. Alright, so we want, whenever the IDs are the same, we know it's the same person, no matter what name they carry or what avatar they carry. If their names are different and their avatars are different, so far as they have the same ID, it's the same person. Alright, so this is it for our entity. Right, we have our user entity. Let's go ahead and create the next module. The next module will simply be our repository. So remember, we have the entity, which hosts the blueprint of the data we'll pass around the layers of this particular feature. In this case, the authentication feature. After that, we create the repository. So it could hold more than one repository, right? So in here, we can call that authentication. I dislike typing. Oh my days. Repository. Dislike typing them out. I normally just do auth repo, and that's it. But for just to be a good boy. Right, so repositories, authentication repository. Let's go ahead and create that. Now this is meant to be a contract, meant to be an interface. It should define how or what this layer, this feature, what functionalities it carries, right? But it doesn't actually implement them. It doesn't give a body to its function, right? So in that case, we will use an interface. In Java, we have interfaces. I think we also have interfaces in Kotlin. I'm not sure. But then in Flutter and Dart, I'm sure that we don't have the interfaces, but we have something similar. We have abstract classes, right? So we can create an abstract class. We can call that authentication repository, right? Boom. And then we can have the constant, oh my days, constant authentication repository. And in here, no, we don't take anything. We just make a constant. We make that a constant, and what do we want to do? So first of all, we want to create user using the post endpoint. And to create a user, I think we should pass in the user. What three things do we need? I think we need the username, the creator, that the name, and the avatar. All right, so this will be automatically generated by the server. So we can use the creator that. So for that we can use required string. Is it string? It could be a date time, but let's make it string because we're basically using a string created at. We can do required string name, required string avatar. Alright, so this is what it looks like. Alright, so now we have to add the type. What type is it going to be? Right, it's going to be a future void, because after we create the user, we don't need any information from the server. We don't want to store its information, right? It will give us back the user, but we don't need it. Alright, we only need the users when we're fetching all users in our use case. Right, so and finally we also have future lists. We need a list of all users. So when we fetch the information from the server, we get all users from the server. We want to store that in the list and create users from it. Right. So we import the users. So list of users. Right. And we're gonna call that get users. So this is what we're expecting. So we're defining the contract. What are we gonna give to it? Nothing, because we can just query the server and say, give me all users that you've got. Right, so this is what we have. All right. Now, here comes the I think it's a little difficult to wrap your head around, but let me walk you through it. So normally this is great and all right. So this is great, but then what if there's an error from the server? What if the server does not this function does not complete successfully, whether from the server or from Dart? Maybe you passed in something wrong here, and your Dart is screaming, "Oh, something wrong's happened." Right? What if the server does not actually complete successfully? How do we know? All right. So in order to know, I really try not to confuse you, but in order to know, we can use two data types, all right? So recently, Dart has implemented records, right? So we could have over here, I don't know, exception, and still have void. So Dart has made this possible, all right? So Dart has made this possible. We have records. If you go to I think Dart 3.10 records were added to the Dart SDK. I don't know what particular Dart version it got added, but it was 3 point something, right? So we've added records so we could know. So now we need to know that this can either return a failure or void. It can complete void. This one as well can either return as an exception or a list of users, right? So they have two return types. But this isn't the way we do it in clean architecture. Clean architecture, we need to use something from functional programming. It's not only in functional programming we use this, but we just need a type that returns two types. So I don't know if you get what I'm saying. So let's see what that means, right? So we could have, when we go over to the pop.dev, we can search for a package called Darts. There's other packages that also do this, but in our case, we're going to use Darts. Darts. So we need to be able to return both a failure. I think my internet is really slow today. We need to be able to return both an exception and the actual type that we need. All right. So in that case, we will use a package called Darts. Here we are. The Darts is opened up. So you can see it adds a bit of functional programming into your Dart project. All right. So this is Darts. Let's go ahead and copy this. Let's go over here and add the Dart package. Dart. Now Dart exposes a data type called either. You see, so it has a left and a right side. So it can have two types. So we basically have two types in one. Right, so we have a left side. In this case, the left side can return an exception. We can have a right side which can return void. So when we save this, we can simply say the result of this function dot left or the result of this function dot right. So if we check and the left is null, then we know, right, that the exception wasn't thrown. If we check and the right was null, then we know that there was an exception. So meaning that this side didn't complete, it was this side that completed. So either one of them must be returned, right? So when it returns the left side, we know there's an exception. When it returns the right side, we know there was success. All right, so let's go ahead and use that. So it will be future either. Over here we can have an exception, but then remember in clean architecture we have to separate our ideas. We have to separate the interfaces. So in this case, we will not directly be dealing with exceptions in the domain layer. All right, in the domain layer, we will be dealing with our own custom type called a failure. All right, so we will create a failure. So a failure will contain the message and the status code from the server. All right, but then an exception will live in the data layer because the exceptions are things that we get from the server from Dart. Remember, the data layer is there to interact directly with the external services. So these external services will throw exceptions at us, and we expect the data layer to catch those exceptions, convert them into a suitable failure for us, and then return them here. So now Dart exposes a data type called either. You see, so it has a left and a right side. So it can have two types. So we basically have two types in one. Right, so we have a left side. In this case, the left side can return an exception. We can have a right side which can return void. So when we save this, we can simply say the result of this function dot left or the result of this function dot right. So if we check and the left is null, then we know, right, that the exception wasn't thrown. If we check and the right was null, then we know that there was an exception. So meaning that this side didn't complete, it was this side that completed. So either one of them must be returned, right? So when it returns the left side, we know there's an exception. When it returns the right side, we know there was success. All right, so let's go ahead and use that. So it will be future either. Over here we can have an exception, but then remember in clean architecture we have to separate our ideas. We have to separate the interfaces. So in this case, we will not directly be dealing with exceptions in the domain layer. All right, in the domain layer, we will be dealing with our own custom type called a failure. All right, so we will create a failure. So a failure will contain the message and the status code from the server. All right, but then an exception will live in the data layer because the exceptions are things that we get from the server, from Dart. Remember, the data layer is there to interact directly with the external services. So these external services will throw exceptions at us, and we expect the data layer to catch those exceptions, convert them into a suitable failure for us, and then return them here. So for that reason, I'm going to go into our lib, create a new file. We're going to call, right? And let's go into errors. Let's create an errors folder, and in there we will create failure.dart. Right, so we will also start by creating an interface first. So this interface will be called failure. All right, and failure will extend equatable. All right, because we want to know if a failure is the same as another failure. With exceptions, we can't really know if two exceptions are the same. Right, so when we're testing, we can't really know if two exceptions are the same, so there's no way to know. This is actually why we need to create a separate class for our exceptions so that we know how they work, right? So let's go ahead and do this. So constant failure, it will have required this dot message and required this dot status code, final string message, final integer status code. All right, so and then we can override I think it's a list of objects get props is equal to, we want a failure to be equal to another failure when the message and the status code are the same. So, and the status code are the same. Now, this is an interface, alright? So in order to actually create our own failure, what types of failure are we expecting? We can expect a server failure, a failure from the server. Right, so remember that data sources, we can have different types of data sources. We can have data sources from servers, we can have data sources from APIs, we can have data sources from the local storage or from the local cache, from the user's device's cache. Maybe we're trying to get something from the user's device, right? And if that doesn't work, then we can get the information from, we can get an error from that cache. So we can call maybe that a cache exception, sorry, a cache failure, right? And we can know, so whenever that happens, we know the problem came directly from a cache. In this case, we're using an API. I'm going to call that an API failure so that we know that it came from the API, and that will extend the failure, right? And in here, we can have a constant API failure, and it will required super dot message. So it simply takes the same thing that the super class takes, super status code. Remember, if you don't understand this, go take our simpler Dart course, simpler Flutter course. Courses, we have a lot of courses on this channel. You can go ahead and take any of them that are beginner friendly. This is for, I think, intermediate developers. So, but then I'm just going to explain, just in case, right? So, what's happening here is we're basically saying collect a message from this constructor when we call that, right? And then pass it to the superclass. So we basically have a failure at the end of the day. So if we call that failure dot message, this message, it will be passed from here. All right, so we have an API failure. All right, so over here we're expecting either a failure, type failure. So these things all are principles of solid. Instead of directly stating over here that we have an API failure, we state that we have a failure rather. So these are I think this falls under dependency inversion, I think. Don't really know all that stuff. So over here we either return a failure or void. Alright, so but then just remember, do not state the actual failure that you're expecting, because in this way, when we do this way, if the type of failure changes, we don't have to go into all of our repositories to change them. Alright, so this is why we call it loose coupling. So if eventually the type of failure that create user expects changes, maybe if we rather want to create user to get a server failure and we have a server failure inside of our failure, maybe we create a server failure and stuff, and then we want this to rather use a server failure. Simply in our data source, when we're returning this, right, we will return a server failure instead, and this can actually still use this. All right, it can actually still work. This class will work. We don't have to touch this class or change any of its existing functionalities. We only extend its functionalities and add whatever feature we want to add. Spoke about this in the previous session. All right, so let's go ahead and do the same thing for you. So over here we have either a failure or a list of user. All right, so now in all of our repositories, so if we had a big application, each repository will use this format, and we will use this same format in our use cases inside of our data, inside of our repository implementations, and a lot more places. In order to avoid all of that repetition, we can simply extract this type because it's long. It's really long. So in order to get that to work, we will extract this into a separate new Dart file. In the core folder, we create utilities. Inside of utilities, we can have type definitions. So type devs are a way to create one short generic name for a type, right? So we can create a type dev by saying type def, and we write the name of the type. So in this case, we can use results future, right? And we can say that result future, whenever someone says result future, we want to know that they're talking about this, a future either failure, import. What is the matter? Import darts. Right, so we want to have a future either failure. But then remember that this part is going to be different for each person. So this part is basically going to be the same. Alright, so this is why also another good strength of clean architecture. The clean architecture makes sure that there's harmony in your code base, right? So with that harmony, we can do stuff like this. Create one type definition, knowing that every single person who wants to use a future either will be sure to have a failure on the left side, and then the actual successful return type on the right side. So in order to do that, to make that generic, we can add a generic type over here and call that T, and then we can pass that T over here. So whenever we call result future, just like either, we can open and close these angle brackets and put in the types. In this case, we only want one type, and that's going to be the type we pass here. If you want to also make this place generic, you can also maybe add another type and just add it here instead. but we're not going to do that, right? Let's go ahead and do this. All right, close that up, and let's see. Right, so over here we can just remove all of this, and we can say result future. It returns a failure or a list of users, right? And over here we can do the same thing. Result future. We can even make one for void, right? So for every function that returns void, let's go ahead into our type definitions. We can make one called type def result void, and then we can just make it to be the result future void. All right, so its other type will be void. So it's basically the same as this, but with void in here. All right, so we can go in to our repository and rather use result void. Right, so that's that for this. Let's go ahead and move on to the next module. So we have our entities, and we're using our entity in here. You can see we're passing them around inside of this layer. So next we have our use cases, directory use cases. Now inside of the use cases, we will create a file, we will create a module for each functionality inside of the repository. Alright, so if we have the create user functionality in here, meaning that we will have a use case for the create user. Alright, if we had one for get users, we will also have a module for that one. Alright, so let's go ahead and do that. So create user, we will call that class create user, right? And this create user will be create user. And now this is where the fun part comes in. So how is this create user going to work? The create user will be depending on the repository. Will be depending on the repository. All right. In this case, we have our authentication repository. It will depend on it, and it will call the create user from it. All right. So this facilitates the single responsibility principle. All right. So in this case, we're depending on the this dot repository. All right. And in our repository, I'm making that a private because I don't want someone else to be able to access it, some other class to be able to access it. Remember, single responsibility. So this use case only has one responsibility. In this case, this person, this contract doesn't have one responsibility. It has more than one. It has create users, get users. But this isn't wrong because this is just a contract. All right. So this is actually where we bring in the actual single responsibility. So authentication repository, and we take that and we can create the function again. I think the function we're doing is create user. So it will be result void, right? The same as result void create user. It will take all of these. So let's go ahead and paste that in here. So it will take all of that and it will simply async, and it will, because the other one's a future. All right, a result void is basically a future. You can see right here. So we can do that and say async. We can just call the repository dot create user, and we pass in everything into it. All right, so this is basically how the use cases should work. But now every use case, right? Every use case is going to follow this same pattern. All right, so again, we're going to do another abstraction by creating an interface. All right, so this is how all of your clean architecture project will be structured. All right, so every use case will simply carry this out and carry out the actual functionality that's related to it. All right, so what is it implementing, or what functionality is it implementing, or what is it going to call? Create user. So we will always override it. So let's create one interface in order to make sure that every single time we create a use case, that use case will follow the same pattern. So this is what the point is with clean architecture. We want to make sure that everything is going to be exactly how it's meant to be. We don't want to leave any room for mistakes from ourselves. So clean architecture is basically you saying I don't trust myself as a developer. I know that I'm prone to mistakes because I'm human. So I'm going to create ways to stop myself from making mistakes. All right. So we create a repository, and we know that every time we want to call um, um, a create user, we know that by force we must pass in these three things, and by force we must pass them in. And we know that by force we will always return a void function. So this is what we're doing. So in this case, we will do this repeatedly for different use cases. So in that case, we can go into our call, create a new Dart file, put it in use case, the use cases folder, and we can create use case.dart. All right. So now we could have two different types of use case, right? We can have a use case that has parameters, and we have use cases that don't have any params, right? So let's go to our repository. So we can see this use case has params, and this one doesn't. So if we go ahead and say we have a class, let's make an abstract class use case, all right? And we go ahead and do this, and we know that each time a use case will return a result future, and it will take some type T, right? The type, right? We don't know the type, so this is us creating an interface. The interfaces use generics, right? Generics meaning we don't hard code what they return because a lot of different modules will be using them, so we don't know what those modules might want to return, right? So result future has a generic type T, right? And then it will have a function called call. So in Dart, the call function exists almost in for every function. All right. So for whatever function you have in your Dart file, all right, you can say that function dot call, and there's this in there, right? So for example, let me show you what I mean. Let's go over to the Dart pad. Let's say that I had a function, right? A function, I don't know. Let's say that I had a function void create user, right? And it does something. Over here, we can simply say create user dot call. You can see. So this will actually call this function. All right. So this is most useful in such cases where, for example, in your widget, if in your widget you're taking an unchanged property, you know these unchanged stuff are functions implicitly, right? So it's a void function, or it could be a string function, or whatever type of function. What if you don't give it an unpressed? Then the unpressed is nullable, right? So how do you know if unpressed is nullable? If you if you did this and you said if it's not call, if it's not invoke it, if it's not null, don't invoke it, then that wouldn't work with the question mark because this isn't how Dart works. This isn't a correct syntax. In that case, what you would do is this: you say create user dot call. So if it's null, call this. If it's not null, call this. And you see that it tells us that the receiver can't be null because this is a nullable, right? So if we're passing it as a nullable value, then we can do this simply. So basically, all I'm trying to say is implicitly, every function has a call callable, a callable call. I don't know what to call this. It has this little thingy. So now that we know that every function has the call functionality, this is what happens, right? The call functionality simply tells Dart that this is callable, that whatever object has it inside of it is callable, right? So also for our classes, imagine that we had a class, right? If inside of this class we had a class, let's see, callable class, right? And inside of this class we had a function, let's see, void print hello. And this function will simply, not async, sorry. It will simply print hello world. Right. So if inside of this callable class we said callable class dot print hello, right? This simply will print hello, right? Because of this would work. But if we went ahead and changed this function's name to call, then do you know what it means? It means that this object, this callable class, is now callable, right? So whenever I invoke this class this way, whenever you do this, right? Whenever you do this to an instance of this class, rather, yeah, that instance of that class will simply call the call method, the call function in there. So we can see if I save this, final callable class is equal to this, and when I do this callable class and I do this, this would work. This works. Do you see? There's no errors, right? An instance of a class is callable. We can run and we can see that this will actually print hello world. Alright, so even if it takes stuff like string message, I'm going to say this dot message. I'm just simply passing the best tag. And we can see that, right? So the instance is callable. So we want similar functionality for our use cases. Why? We want such functionality for our use cases because we don't want to have to say use this use case dot call, or sorry, this use case dot create user, or this use case dot do this or do that, right? So but conventionally we will use the callable object, right? So we make it a callable object by doing this, right? So also remember that some of our use cases need parameters and they need arguments or whatever in them, right? So how are we going to take care of such cases where some need it and some don't? We can create two different use case interfaces, right? So you can say use case with params, right? And we can take the type in the construct, in the declaration, and the params in here as well. So this will be the type, and this will be the params. So let's go ahead and make that type, right? And then the params will be params. So the type is a params type, right? So it will be of this type params. The return type will be of type. The parameter type will also be of type params, which is just a generic type we've defined, right? So we can call that params as well. So we have this, right? So we have a use case that has parameters and it returns the type. We can also have another version, use case without params. We have only a type in this case, and we can have result. Sorry, oh my days, result future type. We can call. It doesn't have any params, right? So we can also make these constant. I just love making everything constant. Alright, so we can make these constant as well. Use case with params rather. Yes, we can make these constant. We can copy that, paste that in here. No, sorry, without params. Let's format the file and we can come back here, and inside of each use case we can append use case. In this case we have params, so with params, right? So in here we can override. When we copy this, then now we have to overwrite that functionality. So this way all of our use cases will follow this same pattern, right? So it has a result feature, and we have to pass in the type and the param type. Alright, so the return type in this case will be void, and the params type will be, we have so many params in this case. If we had only one param, then maybe a string, and we can just simply put string in here. But since we have a lot, we can create a custom type for our parameters. Alright, so this is how it works in clean architecture. I know this is a lot of boilerplate code, but please sit through it. It will benefit you on the long run. So when we have more than one, what we usually do is we create a custom type for it. Alright, so we can come down here and create a class. Right, we can call that create user params, and we also want to use equatable, right? Boom. And we can simply say void create user, create user params, and that's a type for this one, right? So we can have here create user params, and we can just simply async, do an arrow function, and simply do the params dot created at. All right, let me not confuse you. Let me not rush through this. All right, so in our create user params, we know we need 3 params, right? So we need 3 of them. And what are they? Created at, name, and avatar. So we go ahead in here, we create final string created at final string name, final string avatar. And then we can create a constructor. Let me go ahead and generate a constructor. Stop it, generate named argument constructor. If you're wondering how I got that, that's from a plugin. I think that's from a plugin. Let me see. It's from either from you. Yes, named argument constructor. It's from this person, from Andreas Ferenc. I hope I'm not butchering that, mate. Probably am. It's from that person. Don't want to ruin his name, so I'm gonna keep quiet. Let's move this below, following linting rules. So, since we're subclassing equatable, we have to create that missing override, and over here it will be the same params if we have created at name and avatar. Alright, so created at will be the params dot created at, the params dot name, finally params dot avatar. So this is essentially what we've done so far, right? We started out by checking what is our server going to return to us, right? The server is going to return to us the user data after we authenticate this user. So this is one of the things we need, the user's data. So in order to collect that user data into a Dart object, we need to create a blueprint for that object. Right, and the blueprint is this. What does a user data include? A user's data will include their ID, when they were created, and the name of the user. Finally, the user's avatar. Alright, so after that, we move on to the repositories. We define how we want to communicate with our data layer later down the line. We're saying whenever we want to do anything, right, whenever we want to implement any functionality, we must follow these rules. We must have a create user, right? We must create a user. We need to create a user essentially. And when we're creating a user, it must return void. It must take 3 parameters being created at name and avatar, right? And when also we're doing that the same thing for get users, it must return a list of users. And if it fails, it must return a failure. Right, so it's essentially saying this could either return a failure or a void. It could either return a feature or a list of users. Right, so when it fails, when there's a failure, when the result from this is a left result, we will understand that later down the line. Then we know there was a failure. If it doesn't return a left and it returns a right, then it was successful. Then we collect the data from that successfulness, and we do that, right? So clean architecture is basically forcing you to be a good developer. It forces you to be a good programmer. It forces you to handle cases, right? Cases where this has happened and that has happened. It also makes it possible to test these things. So the way these things are, testing them will be pretty easy, super easy, basically. After that, we want to go on and create a use case for this person as well. Use case with parameters. No, without parameters. So without params. And we only give it a type, and its type will be a list of users. Alright. So we go ahead and create a constructor for this. Users will be this dot repository, and we can say final authentication repository. We can override the result future. I think for our create user, we didn't even specify the type for this, so it has to be a result void rather, a result future. So over here we've got a result future that uses a list type. So not a list type, a list of user. How this forces us will be like second call, no params. We simply say async call the repository dot get users. Right. So how this would force us to use to be basically consistent with ourselves is that when I actually change this out to maybe return a string, just scream at me, right? It will scream because this is in the same. So you can see, get users call isn't a valid override of use case parameters call, because this one is looking for either failure list of users as I specified at the top. So when I put a different type here, we know that that's wrong. So you can change that back to users and have that there. So this one is a lot simpler than the previous one. Alright, so now in the sense of test-driven development, you would usually write the test for this before you actually write the implementation for it. But I only wrote the implementation for it first because I'm teaching, right? So for tutorial purposes, I'm writing this first, but usually you'd write the test first and say that the test should make sure that these get called before writing the actual implementation. Now, in order to write the actual test, in order to test for the use case, remember, in here, this is a contract, right? It's an interface. We don't test them. The entities is a blueprint as well, so we don't need to test this. The places that have actual implementations in the domain layer would be the use cases, right? So we have to write tests for each use case, right? So we can go in here and create a test folder, test, right? Inside of the tests, we can create a new direct file. Now we have to follow the same path for this. Why? So that we can easily find our tests. So if we're testing for create user, you can go ahead and copy its path. Let me find that use case create user. We can copy its path. Let's copy from the lib source. We can remove the lib as well. So dart file. We can paste what we've copied. Create user test. Right. So if our class was if our module was create user, we simply add underscore test at the end of it, right? So that's how it goes. That is the convention. We want to start from the source, not from the lib. So we go and create that, right? So we have our file, right? So there's an easier way to do this, right? You can install a package known as Dart test. Let me see plugins. We can see Dart test, this one, all right? So you can simply just right click on your file and then say create new test file or something like that. Create a new Dart test file with the same path in mind. So let's go ahead and test that. I'm going to delete the source and then go ahead and say, no, I have to do that here. New test file. And we can say create user and it will follow the same path and create this for us. So let's go ahead and delete this. So now you have to understand why we're testing and what exactly we're doing in this so-called test. Alright, so Why are we testing? Oh my days, I'm so sorry guys, I forgot about this. Font is more. Let me make that 16. I think that's overkill, but whatever. Right, so what are we testing and why? Right, so in this case we're testing this use case, right? This is so big. Alright, so the reason why we actually want to test this is because we want to make sure that this functionality will function the way we want it to. It will carry out the assignment that we're giving to it as expected. Alright. So each test should focus. So the reason why we call these unit tests, so currently what we're doing is called a unit test, is because it focuses on a small section of your code, a small piece of it, right? A unit. So for example, this class is a unit. So when I say unit, I'm referring to the class that contains whatever functionality we're testing. Alright, so inside of this class we have functionalities. These functionalities are the methods, the functions, alright? So we're going to be testing the functions inside of a unit. Alright, so inside of this class we have several. If we had even more than one function, we'd have to write tests each of the functions to make sure that each function carries out the whatever we ask it to carry out. We can test if it returns what we want it to return. We can test if it accepts what we want it to accept. We can test the process that it takes in order to do that. Alright, so this will prevent any bugs. Alright, it will basically catch almost every bug, right? The only bugs you might encounter might be, I don't know, widget tests, widget bugs, Flutter UI bugs if you don't write unit tests, if you don't write widget tests, that is rather. So basically, the unit tests will be like a safety net for us, right, and for our code basically. So telling it this is how I want you to function. If it's not going to function like that in every case, please throw an error for me now that I'm running the test. Right, so let's go ahead and do that. So inside of our create user test, what is the first thing we have to know? So first things first, when you're testing a unit, when I say unit, I mean a class. When you're testing a class, we have to first of all ask 3 questions. The first question is, what does the class depend on? When you ask this question, we're basically saying, what does this class take in its constructors? Right, so if we're going to test this class, then we're basically going to be initializing this class. So class, we initialize class name, we initialize that class. But if it takes anything in the constructor, it depends on that thingy, right? It means that that class depends on that thing. And then the next question we have to ask is, how can we create a fake version of the dependency? So basically, for example, if our class is depending on an HTTP library, right, we don't want to use the real HTTP library. Why? The reason for this is because we want that dependency, we want to be able to control that dependency, right? So for example, let me give you an example. For example, with HTTP, we can do http.get request, we can send a get request, right? When we send that get request, right, what happens? This will go talk to the server gives it back a response, it saves that response and it brings it back to us. And now we're writing a test. We want to make sure that whenever we call the HTTP library, that it returns something to us, right? But in order to know and make sure that it returns something to us, we have to call HTTP get in our test. But this is a test, right? So if we go ahead and use the raw HTTP library, that will actually will want to make a true call to a server somewhere and then return you its response. Now we don't have control over that, we can't stop it. But when we create a fake version of the HTTP library, then we can then have control over what it returns, right? And we can also control who it talks to. We want to make sure that it doesn't talk to any server, that it's only talking to us, right? Because we don't want to involve any real world dependencies. We don't want to invoke any real world, any real external services in our cases. But we don't want to do anything with the real implementations of these things because then we don't have control over them. And that's where the final question comes in. How do we control what our dependencies do? How do we control everything that it does? This is where another package comes in. And this package, we have actually two packages that can handle this. We have Mocktail and we have Mockito. I prefer to use Mocktail because it doesn't have as much boilerplate as Mockito, right? Mockito, you have to actually define a template and some long stuff. You can look into that later on, but I used to use Mockito before I switched over to Mocktail because it was easier. I mean, clean architecture's got so much boilerplate already. I don't want to have to add my own more boilerplate to my code before it works. So this is what the three questions we have to answer, right? So now let's go ahead and see, what does the class depend on? The class depends on the authentication repository, right? So let's go ahead and create. So now we know, what does the class depend on? Answer: authentication repository. How can we create a fake version of this authentication repository? Answer: use Mocktail. Boom. So now let's go ahead and install Mocktail. But when we're installing it, we want to install it as a developer dependency. Alright, not an actual dependency, because we're only going to be using it in, for example, our tests and so forth. We're not going to be using it in the actual, you know what. So let's go ahead and do that. Flutter pub add dev dependency. You can type out --dev, or you can just do 1d and that's it, and you can say Mocktail. So you can see Mocktail has been added. So Mocktail, you can go online and read its documentation, but essentially what it does is it creates a fake version of this. It hijacks all of its methods and then it lets us control them. Right? It exposes APIs to us that lets us control them. Right? So let's go ahead and do that. This is where we answered this question: how do we control them? Right? Using the Mocktails APIs. So let's start with our test. Right? So now we know what our class depends on. Right? The second thing is, how can we create a fake version of the dependency? We use Mocktail, right? So let's go ahead and do that. In order to do that, we start by creating a fake version of the class. So we can call that fake auth repository, fake auth repo, but more conventionally we say mock instead of fake, right? So mock auth repo. I'm gonna just write auth repo because I don't want to type out that long stuff, but you can do that for, I don't know, better practice. Good practices, best practices, or whatever. Always type out your class names in full. I think everyone would understand what auth repo is. Just for a test. Class mock auth repo extends, so this will extend mock. Right? Mock is from the Mocktail package. This is basically saying this class will be a mock version of what? It will implement, what is it a mock version of? The authentication repository. Alright, so this is what our class is mocking. So this class is going to be a mock version of this authentication repository. Right, so now we've mocked it. We've created a fake version of the dependency, which is the authentication repository. Right. Next thing we want to do is void main start. So the entry point for all of your tests will be the void main. When you hit this, then your test will run. right? But we don't have any tests yet, so I think that's not gonna work. So see, yeah, that's taking too much time really. There's no test. I'm just gonna stop that. Yeah, no tests were found. Great. So now we start, right? How do we control what our dependencies do? Right, so we will answer that question later when we need to control what our dependencies do. So let's first of all start by writing our test. In order to write a test, you can use the test from the Flutter test package, which is also automatically added in every Flutter project by Flutter themselves. So you can run test, right, and it needs a description. So the convention for the descriptions are usually this test should, or this unit should, it should do what? It should in our case we want that it should, and what are we testing? We're testing create user. So it should call the let's see, repository dot create user method. Right? I'm putting this in square brackets, it's just something I like to do when I'm talking about class, right? So because I'm talking about the auth repository, we can say auth repository, auth repo. I don't want this to be too long, so auth repo.create user. We want to make sure that it always calls the auth repo dot create user, right? And we can add an async because we have to await a function, a future function, right? So now we want to make sure that it should always call the authentication repository dot create user. How do we do that? Right, so when we're testing, we follow 3 simple steps. We have the arrange, that is the first step. We act, and finally we assert. No, stop. So we arrange, we act, and then we assert, right? So what does arrangement mean? Right, so it's AAA, right? So arrangement means that we're putting together everything we need for our function to work, right? So what function are we testing? In this case, we're going to be testing the use case. So we're testing the create user use case. So we want that use case, and we want to call .call. So each use case has .call inside of it, but because it's a call, we can just invoke it directly, right? So we just want, whenever we're calling that, does it need any information from us? Yes, it does. What does it need from us? It needs a create user params, right? So we can go ahead and add a create user params and instantiate it on whatever, right? But then where's our use case, right? So first of all, we need to get code of our use case. So let's go ahead and save that here. So we start with late create user is our use case, right? And we can, now it's late, right? Late means we're promising Darts that before we use it over here, we must have instantiated it. How do we instantiate stuff in tests, right? We can't just do use case is equal to something, right? Because if we do that, then we only have one instance of the use case living throughout this. So if we actually used that use case in here, right, and then maybe change its value somewhere along the line, then the subsequent tests, the tests that follow, will also be using that same modified instance of the use case. But we want a case where for each test, if we had 3 tests in here, for each of them, we want a new use case to be created. So we can do that in something called a setup. Right, the setup is also from the Flutter tests library, Flutter test package rather. So in the setup, it simply means do this every time that we start a new test. You can read it here. So it registers a function to be run before each test is run. Right. So if we had three tests here, and then in the first test we actually changed something. Maybe we arranged by saying that the use case dot whatever, maybe the use case dot, if it had a name, is equal to something else. Then when we do that, when we get into the next test, it will instantiate a new use case for us. all right, instantiates a new one. So that way we don't have to layer out or whatever, right? So we also have the setup all, right? So this will do this once for everyone, right? So this is it. Registers the function to be run once before all tests. So this will actually run once before anything else is done, right? And it will not be run again and again after each test, right? So after this test completes, it will still be the same use case instance that goes on to the next test. So in the spirit of all that, let's go ahead and continue with setup. We can make our use case to be equal to create user. We instantiate a new use case. Now, what's the problem? The use case wants a repository, right? So we've already mocked our repository. So why don't we go ahead and also create a repository? So the reason why I'm creating this repository separately and not just creating it in here is because when we're arranging, we're actually going to be using it, right? So late authentication repository repo or repository. Let me just follow those syntax, and then we can say repository is equal to the mock auth repo. We don't want to use the real instance of it. We want to use the mock version, and we can say that that will be our repository. Right. So now we get onto arrangement. Right. So if we had a function, right, we're trying to say call our function, right? Our function is the use case, right? When we call the use case, so when we call this, it will be an act. So we're acting on something, we're carrying out an action, which is invoking the use case. It needs some params, right? So what params does it need? It needs the create user params. We can go ahead and create a create user params, and we can give creator that name and avatar, right? I'm going to go ahead and make that a constant, right? But then this shouldn't be here. This should be in the arrange. So we arrange everything we need before we act, right? So we can say final params is equal to this. So this is what arrangements do. So we arrange whatever we need and we put it in here, right? Params. We can save that in there, right? But then in clean architecture test, so this is how normal testing a normal function would work, right? We arrange everything in there. But in clean architecture tests, remember the third question. We want to control what our dependencies do. We don't just want to act and give it these params. We actually want to control what it returns, right? Now, how does this use case return something? The use case does not just carry out its own function and return something. The use case actually depends on the repository. It calls the repository's function, and then it returns whatever the repository's function does. Now, who does the repository talk to? The repository does not talk to anyone. Right, so meaning that the last person in our chain of command is the repository. So the repository is the main dependency, right? So we can then arrange what that repository will return, right? So let me go over that again. We want to control or arrange what maybe the parameters that we use over here, or what this use case will return. This is what we want to control. We want to control what it returns at the end of the day. In order to control what it returns, we don't control this person, because this person isn't actually doing anything, right? This person is actually listening to a higher up, someone up in the food chain, and then they're getting their command from them. So if we want to change something, we actually go to the higher up. We go up there to the presidential level and we talk to them. We say, listen, whenever this happens, you do this. So the use case is listening to the presidential. If we get to change the presidential, sorry, I'm getting into politics. I'm no politician. But then if we get to change or control the president, then we essentially are controlling the constituents, basically. We are in control of everything, right? So now that's what we're going to do. We're going to be evil cabals and control the president. Who's the president? The president is a repository. So we will say, sorry for not telling you about this. We will say when, right? So we're trying to, so it's basically like simple English. right? But the when is from the mocktail library, mocktail package, right? So we can say when what, when a function. So this is simply saying when we invoke or when a higher order function calls, when someone calls what? When someone calls the repository, when someone calls the president, when the use case calls the president and says president create user, right? But for what? Create user. Now we have to put in the arguments that it wants, right? So now that's the problem. How do we create these arguments, right? In mocking, when we have a class that we're mocking, right, in the when block, when you're creating these, you can use a keyword called any, right? And you can invoke that. Any simply means find a null value and use it for this, or sorry, find a generic value and use it for this. So first of all, checks the type. So the type for created at is a string. If it's a Darts data type, so for example string, integer, and the rest of them, it will create a default value. So for string, it might create a generic string called created at. It might just do this and put it in here, replace it in here. You can read the documentation for an argument matcher that matches any argument passed in. So it will simply just create and find out the type for it, and then create a string that will match that. All right. We're also going to do the same thing here, and we're also going to do the same thing here. Now we have a named one. So we have a named param that we need to pass. Now, when we're doing that, we have to come inside of the any when it's named and say named, right? And we put in the name of the param. In this case, name. In this case, avatar. This is how it works. This is just convention. You don't have to beat yourself up over it. If you don't remember it, come back and look the format for it again. So now we're saying that whenever someone contacts the president, says, listen, sir, I need it to create a user for me, right? What should the president tell them? Now, Mr. President, we want to hijack your response and we want to say dot then. Now we have three versions. We have then throw, we have then answer, and we have a then return. The then throw will come in handy when we're trying to force the dependency to throw an error, because we want to test what happens when an error occurs, right? But this isn't the case. We want to test what happens when it's successful, basically, right? So when it throws, when it's successful, right, then answer, right, it should then answer or then return. Then return works when your function, this function, is not async, right? So because of this function is actually an asynchronous function, we can see it's a future function, right? We need to use then. We need to use then answer, right? So then return would be for a function that is not, we're not expecting or we don't want to wait for it, right? If you want to wait for the thing to complete, like a future, and then we simply say then answer, right? We use then answer, so answer after. So store a function which is called when this method stop is called, right? So it hijacks this method, so whenever it's called, this answer will be given. Right, so now what type of answer is create user given? Create user is given a void. Right, so how do we mimic void? So we need to put this. So this takes an invocation. This is some high level stuff. We're not going to be needing it, so we're just going to put in that. And then we'll return something. So we can return void. But then now you have to remember async. We're going to put async before this. So now we have to remember though, right? Oh, is the problem? It's your problem. Done. Expected what identifier? Let's see. Yeah. So you can see that the return type not. So it's actually returning void, right? So the return type not is not a future either value. So this doesn't just want one value, right? So we're expecting an either right or left value. So in our case, because we want to mimic success, right, we will rather use the right, because the right, mostly conventionally, we put the success on the right and the failure on the left. So when it's the right hand side, so we want to return a right hand side answer. The right hand side is from the darts package. Right, so right hand is a subclass of the either. So an either can either return a left or a right. So when it's a left, we know it's a failure. When it's a right, in our case, it's a failure. When it's a right, we know it's successful, because in our case, we've put failure on the left and success on the right. So when this gets called, we want the president to say, you're right, you have success. And what type of success is the right expecting? It's expecting a void. But we can't put void in here. So whenever you have a void function, inside of your right, you put null, right? Because it's void. So we can't just put void in there. So we put constant right null. So whenever someone calls create user on your repository, we want you to give them back a right answer. All right. So now that's us setting up hijacking. This is called stubbing. So for our arrangement, we stub. We're hijacking the president's response to whenever this function gets called, this particular function gets called. So now we act, right? So we can say that our use case, we invoke it and we have to act, right? We have to pass it the params. Now we have to create the params. We have to come here, final. No, let me create that right here. Final params is equal to create user params. Now we have to do this over and over if we have multiple stuff. So in order to just make this simpler, for every class, what I personally do is, for every class that I create, I add an empty constructor. So constant create user params dot empty. All right, and what does this do? This will return this class, right? You can just do this, you can change it to a factory constructor and do this, and it returns create user params, and then you pass in the default values, but I prefer to do it this way. So I will return this, and this will have created that, and I will pass that I don't know, empty string. The name will also be an empty string, and the avatar empty string. You can name it any, you can do anything you want with them. You can just put them and just leave them empty, or you can use their names, empty dot created at whatever you want to do, but it's up to you. But I'm just creating these because I don't want to have to always invoke, create new versions of create user params each time I'm writing a test for whatever uses it. So I'm also going to do the same thing for my user. So where's my user? So I'm going to go into entities. My user, I'm actually going to create a constant user.empty. This, I'm going to do ID will be 1. Created at will be empty.created at. I'm going to do the same for name. Right, so let's go back here. And here, so my params will simply be create user params.empty. Empty, right? So that will create a user params for me. I don't have to always instantiate it with empty values anymore. So we can just simply take those params and we can pass them here, right? So now that we've acted, we've carried out this. We have to wait for it because it's a future, right? We wait for this to complete, and then we assert. what are we asserting? We're asserting to make sure that this got called, that when this got called, that it returns the right data, and also we actually want to test that it actually even called the auth repository's create user method, right? So how do we do that? Let's start by making sure that it returns the right data, right? So what data are we expecting? We're expecting a write null, right? A write void function. So let's go ahead, write the void result rather. So let's go ahead and save it in a variable called result, right? So what do you return? You return a future either, whatever, right? So, and then to assert that the values, so if you want to assert values and make sure that they're the same, assert two values or equate two values in the test, you use the expect function from the Flutter test package, and now it's asking for the actual thing we want to test. We want to equate something again, so we're expecting that the result. So this is basically like simple English, right? When the president gets called, so when that happens, the president responds to this for reasons best known to him. And then we go ahead and test the president. We say, "I've told you, you must answer this way if he calls you." And then we go ahead and make the use case call the president. We say, "Hey, use case, why don't you call the president and see what he says?" So we go ahead and call this, invoke it. It gets invoked, and now we're checking. We're going through the president's call history to listen in on his conversation with this person, and we're saying, "All right, now we've got the result of the call that you made with him, Mr. President. Better hope that you told him what we told you to tell him, right?" So what do we expect that the president told him? We expect that the president told him something, so we expect that the result equals. So you can totally do this without equals, but I prefer to wrap in equals, right? It makes sure that it's equal to this. If you leave the equals out, it actually does the same thing. But I don't know. I just like doing that. So we're expecting that the result or whatever the president told you is equal to a write null. Because this was what we told the president to tell you, right? So usually this is great, but personally, for best coding practices, I prefer to state the data type. So what is it? It's a write. It has a left and a right. So what were we expecting on the left? We're expecting a failure. So write failure, and on the right we're expecting void, right? But then remember that there's this fail. I don't want to have to import it each time. So what I usually do, if I'm using the right type, on the left I put dynamic. If I was using the left rather, right, on the left I will put the actual value, and on the right I put dynamic. This is what I do, right? So that way it's easier for me without having to import what I don't need, because I don't need this in this place, so I don't have to import that. And then so this is what we're doing. We're expecting that Mr. President said what we told him to say, being a write null, right? Forget about this long stuff. What it's just, I don't know. I just like doing that. And then we verify, right? Now this is where we're verifying that this little guy actually called the president. We should make sure that this person called. So now we've got the call log, right? So what if this passes and it tells us yes, the president actually told them a write null, mate, right? Then how do we know that that call even actually went through? How do we know that the use case made the call that we asked him to make? Right? What if this person is lying to us? What if the histories were fake? What if the history was doctored, basically? Right? So we would have verified that that call actually went through. So we have to use the verify function. So similarly, the same way we do this, we want to verify that the repository .create user got called, and it got called with these same values. We want to make sure that the use case told the repository, told the president exactly what we asked it to tell the president, right? So what did we ask it to tell the president? We gave it params. These params are right here, right? So we want to make sure that when the president asked for a creator, that it told the president params.created@. When the president asked for a name, it told him params.name. When the president asked for an avatar, it said params.avatar. So we want to make sure that this call went through. And we also, you can actually leave this way, but for scrutiny, but personally, this is what I do. I prefer to say .called once. We want to make sure that you didn't call the president a second time and tell the president a lie, or tell the president, look, he's threatening me, please answer this way, so that it goes into the call history. Right, we want to make sure that exactly the call went through exactly once. You call the president only once, because we want you to only call the president once. We don't want the call to be repeated. So when we come here, we don't want a case where this thing gets called twice, because we want it to get called once. Each time that person gets called once, because we're actually calling it once over here. Right? So now for that, after that's done, there's one last verification we have to do. We have to verify no more interactions with the president. After that call went through once, we have to make sure that he didn't send any letters, he didn't do any hand signals to the president to say, sir, he's threatening me, or whatever, right? We want to make sure that there was no more interactions with the president. The president was not interacted with, right? So this is our test. We're saying that whenever the president gets called, we're arranging an answer for the person that calls the president. We're saying, Mr. President, you have to tell them this. When they give you any value for your creator, that when they give you any value for your name and any value at all that they give, so it doesn't matter what they give to you for creator that name and avatar, always answer this way, no matter what they give to you. So even if a different use case calls the same function and gives different values for this than we gave in here, right? Always answer with the same answer. Say right, no mate, right? So we then go to the use case and we say, you, listen, call the president right now and only call him once and tell him this, tell him empty. Tell the president that creator that is empty.creator that. Tell him that name is empty.name. Tell him that empty, your avatar is the avatar. And finally, we check if the answer that the president gave was correct. Then we check to make sure that he called the president, and we check to make sure that he did that only once. And for extra security, we want to make sure that he never interacted with the president after that, right? So let's go ahead and run the test and see if the test passes. So this is our first test, and let's see what happens. Hopefully it passes, fingers crossed. So we can see the tests have passed. So we have one passed test, right? If we go ahead and where is it in our create user? If we go ahead and do something differently here, right? So if inside of this place, where is it? If inside of it, oh my days, stop. If in here, instead of giving the creator that we were passed in the params, we decided to give it a different creator that, maybe something different, then the test will fail, right? So let's see what happens. The test is going to fail woefully. Do you see that? So no matching calls matches exactly what we wanted, because they went and called something different. Oh, creator that, you really did that. Now you're in trouble, mate. So now we know exactly what he did wrong. We know that he's not doing the right thing that we want him to do, right? He's a bad person, so he doesn't listen. So let's go ahead and correct him. So you must use creator that, and now it works, right? So whatever we do wrong here, the tests will fail. So that way, there's no bugs in our end application if all our tests are passing. So let's go ahead and do the same for get user. Was a get user, get users rather. So let's go ahead and create a new Dart file. No, should I do it that way? New Dart file. Dart test file. Get users. Now we have to do the same process again. Let's go copy our code from before. We're not basically copying, we're just peeking. Oh, also, yeah. There's this. When you write a test for a class and you right click inside of that class and go to, if you want to find the test for particular class easily, you can do this go to and go to test. It will take you to the test of that file, right? It simply finds that file at that particular path with an underscore test in it. Alright, so you can also see the icons are different because they're in the test directory. So now also, let's go to your tests, go to tests. We can see the process that we've done, right? First of all, what does the class depend on? Auth repository. How can we create a fake version of it? We use Mocktail. How do we control it? Use the Mocktail's APIs. In this case, we control it using when, the when API, right? So now that we know how that works, let's go ahead and do the same thing for get user. Now get user also depends on the same repository, so we could either copy this, right, or we could simply copy this and paste it in there. But then if we had 10 use cases, then we'd have to copy and paste this repeatedly. So in order to prevent all of that, I usually do one thing, right? I come here and I say new Dart file inside of the test, and I use the name of the repository. So authentication repository.mock.dart. So you can see it has a different icon. You can see it over there. It has a different icon. By the way, I'm using the material 3 icons. Let me show that to you. It's Atom rather. So it's the Atom icons. This is what I'm using. So that's why I've got these beautiful things in here. So I could just paste that in here, import Mocktail and import the authentication repository. And in each file, we can just simply import that authentication stuff. So in here, we can go ahead and say that the void main, right? Remember what we did. First of all, we need the repository. So authentication repository, repo repository, and we also need the use case. In this case, we need to get users use case, and we do the setup. We need setup async. No, we don't need async. Give me father. So we come in here. We say repository will be equal to, we're instantiating the repository first because the use case depends on it. So the use case would take that in its constructor. So before we create the use case, we create a repository. Well, let's go ahead and do that. Mock auth repo. This is what I mean. So when we do the use case, will be equal to get users. It will ask for a repository. If we hadn't already instantiated it over here, it will throw an error. Let's see. If I go ahead and pass it that repository, you can see it says the late local variable is definitely unassigned at this point, meaning we haven't assigned it a value. So else we assign it a value. So now that that's done, we can go ahead and say test. Right, its description should, remember that in the previous one we were saying it should call. Where is it? Where is it? Where are you? Where are you? It should call the authrepo.createUser. In this case, in that case, we weren't returning anything. It was returning void. So that was why I left it with just one functionality. So over here, we're testing that it should call the, no need for the authrepo.getUsers, right? And it should return lists user. So after that's done, let me go ahead and format this. Right, so now we start by arranging. Let's arrange by stubbing. Let's stub and hijack the president's response to this time the get users. So whenever, let me tab that so it imports Mocktail for us. So whenever a higher order function calls you, Mr. President, repository.get users. It doesn't take anything, right? So we can leave that empty. But then answer with an invocation, which we don't need, we don't care, Mr. President. But we could go ahead and say, what do we want the president to tell them? We want it to give them an empty list of users. Or since we've already created an empty version of the user class, we can just simply create use that then. So let me go ahead and final test response will be equal to a list of user.empty. Right, so now we don't have to instantiate them, so we can go ahead and say return a right, because it will return a right version of it, so t response, which is a list of users. Now we can act, and for our act of the day, we're going to be forcing this person, we're going to be blackmailing this person result, await Mr. Use Case. We're saying go ahead and make the call, Mr. Use Case. Don't use anything, Mr. Use Case, and we can expect that the result of that call will be a right. Now you might think that equals const right dynamic on the left, and on the right we have a list of user, right? And in here we will have the t response. Now we want the result to be equal to that, and you might think that this would work. Let's go ahead and run that test. That works, so we are getting the response that we're looking for. So let's go ahead and verify that this man did in fact call the president. So repository.getUsers actually got called, and it got called once. We don't want it to get called more than once. We also verify no more interactions with the president. Have you reported me to the president? Use case. Let's go ahead and run that. That should work perfectly. Beautiful. So now we're sure that both of them are working perfectly. Both the create users and the get users are working exactly as we want them to. Right, so that's it for our use case. The use case is done, its test is done, the domain layer is done. And now finally we can move into the data layer. Alright, so let's go ahead and create a model. So the first thing, we want the data layer. Inside of the data layer we have the models. Inside of the model we have the user model.dart. Boom. So you can make this part easier, but I'm gonna write out the code by hand first, and then I will show you how to generate this code easily. You might already know how to do that if you're already a Flutter guru. So I know that some of you are. Let's go ahead and do that. Class user model extends. It extends the user entity, right? So it extends the user entity. All right, and then now we have to say constant user model, create a constructor for it. Now because it's extending the user, we don't have to collect the information as properties, final, username, final, because the parent class is already collecting them. We simply have to collect them in our constructor and pass them to the superclass. Right, superclass.avatar required super.id required super created that required super.name. Alright, so now that that's done, let's go ahead and start creating or extending the functionality. Remember, the entity is the blueprint and the model is the extension of the blueprint. We're building upon that blueprint, right? So let's go ahead and do that. So the first thing we want to do is to add serialization from JSON and to JSON. In this case, from map and to map. From map and to map. I prefer to call them that because JSON means JSON, right? If you know what JSON is, it's usually in the form of a string. It's different from a Dart map, right? So in our case, we're gonna have user model dot from map, right? And this would take a map string dynamic. This is too long because we're going to be using this over and over, so I'm going to create a type definition for this right here. Utilities type def. I'm going to put this here. Type def. I'm going to call this a data map, right? Is equal to that. So whenever we say data map, we mean map string dynamic. That's good laziness, really. Good laziness. So we have a data map, and we can call that a map. And we in here we can say this, and it will return this. It will return a user model, right? We can add constant over here, and in here it wants the avatar. The avatar, where I'm gonna simply give the map at avatar as a string for the what else have we got? For ID, we're gonna give map at ID as a integer. For the created at, we're gonna take map at created at. Let me put that in there as a string, and finally for the name, it's gonna be map at the name as a string. What have we done here? What is wrong? Oh, invalid constant value. I'm so sorry about that. So what are we doing here? So we've gone to a server and we know that the server, this is what the server returns. So whenever we make that call, right? Whenever we go over here and we say get me a user, get me users, right? Where is it? Get users, whatever. Whenever we come here and we say get users, it will return us a list of these users, right? If you want to test this, let me show you how to test, right? You can go ahead and copy this endpoint, right? So copy this and paste it in your browser. We can paste that and we can go to endpoint users, right? Users, and we hit enter and we can see an empty list. So let's go ahead and let's create a fake user. No, I want only one user, please. No, only one user. Alright, mate, let's create one user. Can you not just do one user for me? No, it doesn't. Alright, I'm just going to do two then. So data generated, when we refresh this, we can see two users, and this is the form that the users come in. I think we can also see this when we click on data. Yeah, we can see, but this is a mess. I don't like looking at this. If you want this endpoint to, or if you want this whenever you visit an API and it has to display JSON for you, normally it would display them in ugly format. If you want it to be formatted this way on your browser whenever you visit this, you use an extension. I have an extension, I've forgotten what it's called. I will find that extension later, or you can just search for JSON extensions or something. So you can just Google Chrome JSON extensions and you can see JSON view. I think I'm using this one, and you can install it into your Chrome. And whenever you visit any endpoint that will return a JSON, it will format it this way and it looks pretty. Let me go ahead and change that to dark mode. Dark. Yeah, a lot of ambiance. The ambiance. No, I prefer this one. So let me save that. Alright. Let me go ahead and reload that. You could see. Right, so yes, this is what I like to see. So this is what we have. So when this happens, we will be getting a user data. We'll be getting user data in lists when we're getting the users. Now each user data contains created at, name, avatar, and ID. Oh, and the ID is also a string, so let's go ahead and change this to be a string. So over here, a string, so you can see, so we have to structure this as it is in the from the server. So in the server, this will also be a string, right? So over here, we also have a string, right? So everything's fixed now. So now we're saying when we get that data from the server, we actually want to take that data and pass it to our user model.from map, right? And we from that map we can extract the avatar ID created at a name, right? So when that's done, how about if it was received as a JSON, as an actual JSON, right? As an actual, because this will come in the form of a JSON, and JSONs usually come in the forms of a string. They usually come in forms of strings, right? So let's go ahead and create one for that. So user model dot from JSON, right? So what would this do? This will take a string source, so the source of the JSON, and it will do what is it going to do? It's going to return the user model dot from map, right? And what is it going to give it as a map? It's going to do JSON decode, right? JSON decode, and it gives it the source, and it will return it as a data map. Isn't that brilliant? Let's go ahead and save that much. And what is your problem? Dart convert. And what is your problem again? Constructors cut. Oh, sorry. This has to be a factory constructor. Right, so finally, let's go ahead and create the rest of them. Oh, I'm getting tired. So use them. No, this time we actually want to create the two. So when we're sending data to the server, how do we want to do that? We want to do two. So data map to JSON, to map rather, and this will return a map version of what we have. So the ID will simply be the ID that we've got. The avatar will simply be the avatar that we've got, and the created app will simply be the created app that we've got, and the name will finally be the name that we've got. Right, so that's it for the date for the to map. What about a to JSON? Data map, sorry, string to JSON will simply do what it will take the to map. So we're gonna do a JSON encode to map. So we're gonna call the to map and then code it into a JSON format. Right, so this is it. But now remember that our class is extended and equatable, right? And each of its fields are final, meaning that we can't change them. So what if we had a user and we wanted to update the user's data? So in this case, the user's name, right? What are we going to do to the current user? We can't say user.name is equal to user.name. Maybe we can create void final user is equal to user.empty, and we want to change their name. We can't say user.name is equal to Bing or Google, right? We can't do that. Why? Because here you go, name can't be used as a setter because it's final. So in order to fix this, we have to add a copy with method in our user model. Right, what does copy with do? Copy with gives us a way to recreate a new version of the object with the new values that we've passed to it. Right, so this is how it usually works. In the constructor of the copy with method, in the signature of it, we take each property of that class, but we make sure that they're nullable. Right, so let's go ahead and build it out so you don't get confused as I speak. Let's go ahead and do this. So we can see it will return a user model, right? So we want a user model after we copy the data over, right? So we will copy with, right? So what do we want to copy across? What do we want to copy across, or what do we want to change? What properties do we want to change? So what properties do we have then? We have the string avatar. We're making it nullable because what if what the person wanted to change was only the name? we can't force them to change the avatar ID and create that. So if they give the avatar, then we know they want to change the avatar. So we keep the rest of them the same way, and we only change the avatar. So let's go ahead and do for the rest of them. ID string created at string name. We want to make each of them nullable, because what if that's not what we want to change? And then we can simply do this, and we can return a new user model, right? And that new user model will have, let's go ahead and format this bit. All right, so now that user model's avatar. What avatar are we going to use? We're going to use the avatar that we've got here. And if they haven't passed that avatar, we will simply use the already existing avatar of the object, right? So if we already had the user, then that user already has an avatar ID created at a name, right? If they didn't give an avatar when we're copying with, it simply means that the avatar, they don't want to change it, they want to keep it, they want to copy the existing user model by changing the name, but then copying the new user model along with the old values kept. I don't know if you understood what I said. I don't even know what I've said, but this is basically what we're doing, right? So we're simply saying, for example, we want to change the name. When we say, let me go ahead and do this. Void main final user is equal to user.empty. No, let's go ahead and do it with the user model, because the user itself does not have this, remember. So when we want to do extensive stuff, we want to do so. This person also needs an empty function, so I'm just going to copy this one over. Copy that one over. It returns a user model. Beautiful, beautiful stuff. So we have a user model.empty at const modifier. Change this version to constant. No, stop. We want to change this to a constant. Remove the constant over here. Right, so if we want to change the user's value, this user's value, then we have to save it to a new user. So final new user will be equal to the old user dot copy with. So we're simply trying to change their name alone. We want their name to this time be Paul, right? So this is what we're saying. Essentially, we're saying take the old user and copy all of their values, all of its old values. In this case, the avatar, the ID, and the creator. That copy all those with this new value, right? So copy the ones that I haven't changed here with these ones. So if it was only this one, then we would say with this one that I've changed. If it was more than one, so for example avatar, then we're copying with these ones, right? So with the new avatar as well. So this is essentially what we're going to be doing when we want to create new versions of our stuff, right? So if the ID is empty, use this.id. We're going to do the same thing with created at. We use this.created at, right? So if you want to know how I did that, I simply did Command D. So I copied this. Sorry. I copied this and I did Control D. It just gave me that. So I'm saying this is not use this.name. Right, so this is our copy with. Now, if you don't want to have to go through the stress of writing all of this yourself, you can simply go over to your user, right click on it, and say generate. Why don't we do it in the user model? Because it wouldn't work. Because the user model doesn't have any properties. It only takes stuff in its constructor. So for the generator to work, it needs to know the properties. In this case, we have the properties defined here. So this is why we're doing them here. So you can go ahead and say generate. You can generate copy, and you select everything. Right, select everything because we want to copy with everything. Right, so copy with for us. We can go ahead and generate a to map and from map. We can also do that and it generates them for us and so forth. But I prefer writing them by hand. Right, so we can either do that, and after doing that, we copy them. Make sure you cut them. You don't leave them in here. The entity is just a blueprint, and then you put them in here. You come and paste them here, and that should work for you. right? So you can see now that this has become a parent, right? It's a happy parent and it's proud of its children, right? So it's telling us, look, I have a child. Do you want to see my child? When I click that, it takes us to its child, right? So that's the beauty of that. Now we have something sending this. And now for the user model, we also have to write tests. The user model. We have to test every single class in here, every single every single method in here to make sure that they work the way we want them to. So that's what we're going to do next. Model testing. And now for the model test, we're going to do the same thing we do. This is new dart test file. User model. Boom. Now, do you remember the three questions that we had for each unit test? We had three questions. First of all, what is our dependency? What does our unit depend on? Secondly, how do we fake the dependency? How do we create a fake version of it? We use mocktail. And finally, how do we control what that fake version does? Still using the mocktail APIs. But in this case, we can go over to our user model. The user model does not have any dependencies. It does not depend on anything at all, right? So there's no external stuff that it depends on. So in this case, our unit doesn't really have a real dependency. The user model does not really depend on anything at all. You can see there's nothing that we're collecting in the constructor that has to do with a dependency, basically, like something that we take into the constructor that we have to use across the other functions or in even one function at all. So in that case, we can just go ahead. We don't need to mock anything at all. And go ahead and start, right? So in this case, we're going to introduce something called a group, right? So first of all, you've seen the test, right? The test is this. It will give you the ability to run tests on a particular unit or on a particular method, right? Now we have a group. The group lets you group tests, right? So you can name the group. So for example, in this case, we have the from JSON or from map. Let's start with from map, right? And inside of the from map, then we can have different tests, right? Test one, and we can have a second test and so forth, right? So, but then first of all, let me remove this. The first test that you always want to run for your models is to make sure that the model is a subclass of the entity, right? So test should be a subclass of user entity. So let's go ahead and arrange. So we can arrange by saying final T model is equal to user model.empty. So we have an empty user model. We can go ahead and say that model. So we can expect. So we're going straight to assertion. So we don't act because we don't need to act, right? We don't need to act because there's no functions to call. So we just go to assert. We don't have to act on anything. We just want to make sure that the T model is a. So when you want to check that something is a something, you put is a, and then you put angle brackets, and then you tell it what you're expecting that it will be a type of. So we expect that it will be a user, and then we invoke the isA function, right? So we want that to run. Let's go ahead and see. We want to expect that the T model is a user, and we can see that passes. It's a subclass of the user entity, right? So let's go ahead with the next test. So what unit are we going to test? What method are we testing this time? The first one is from JSON, but from JSON depends on from map. We can test this first totally because they're loosely coupled, right? It would still work, but personally, I just love to follow the conventions. I don't know, just like doing that. Group, boom, from map is what we're testing for this group. Now, what is the first test going to be? Test. The first test should make sure, or should, we're expecting that it should return a user model with the right data, with the correct, or we can just say right data, it doesn't matter. Now we're going to arrange, right? What is our arrangement? Our arrange is to create a T model, but I don't think it's crazy to just have to create that in every single part. So we could just create that up top and use it generally for everything, basically. So we can simply make sure it asserts that arrange. So what is our second arrangement? We want, all right, let's go first of all go to act. We can act and say that the T model, or sorry, final results will be equal to user model dot from map, right? And what map are we going to give to this person, right? So what the map, let me go ahead and remove this as well, because we already have that generally for everyone who needs to use it. So what map are we going to give this person? So now we can see that this person depends on a map. So its dependency is a map from the server or something. In order to create this map, we can go ahead and create it up here, right? But then for convention, right, for JSON testing when they're JSONs, we have to go ahead and create our own JSON instead of creating a Dart map, because in this case we want to mimic the server to the core of it. We want to see this to the very end of it, right? So inside of our test folder, we're going to create a directory called fixtures, right? And inside of the fixtures, we can create a new Dart file that we're going to call that a fixture reader, right? Inside of our fixture reader, first of all, let me show you what we're going to do. So first of all, in our fixtures, we're going to have a fixture for all of our models. So a JSON file. So it's going to be a .json. So this is how our server will actually return it in the JSON format. And then we have to read that JSON, convert it to a map, convert it to a JSON, and finally, do all of that. So first things first, let's go ahead and create this one. This one's going to be a user.json. What is a user going to contain? Let's go ahead and copy our example, right? It's going to look something like this, right? So this is what our user is going to look like. So let's go ahead and change these thingies, right? So inside of our user model test, inside of our user model test, we can see that we have that little JSON in here, right? So how do we get this JSON from here and convert it into a Dart map in here, right? For that, we would have to do this. Where should I do this? Maybe here. Should I arrange it here? Let me arrange it in here. We can take that out later when we need it somewhere else, right? So tmap, or first of all, the tjson first of all will be equal to the JSON file itself will be equal to file, right? And the path will simply be test / fixtures / user.json import .io .read as byte sync. We want it to be synchronous, right? So now we've got a JSON file, right? Let's go ahead and print out that and let's see if it actually reads it properly. So let's see. Sorry, I haven't printed that. Print the tjson. Right. Oh my days. No. My bad. So we can see I mistakenly read it as bytes. So we can see that it gets us these values right here as a JSON. Right now we have to convert this into. Now this will be a string at the point when we get it. You can see it to string because we're reading it as a string. We want to convert it into a proper Dart map. in order to do that, we have to JSON and decode blah blah blah, and we pass in the JSON, right? But now we in our application where I'm gonna have several models, not only one. So when we're testing all of them, we want a generic way of converting our JSON fixture files into actual JSON strings, right? So for that reason, we're going to come into our fixture reader and we're going to create a string fixture function. It will take the path, no, let's call that a file name rather, because we know the path is going to be test fixtures and then something. So file name or something, file path, or file name. Let's go with file name. Means that, and we can go ahead and return this, right? So test fixtures file name, and that's it. And for you, my friend, we return the .io. So we generally wouldn't be able to use this across our tests. This is why we're creating a new file for it called fixture reader. So inside of our data, this place, we can create. Let me go ahead and create this up top, because a lot of other people will be using them. Like a lot of other functions will be using them. So up top, I'm actually just going to create this. I'm going to call this final tjson will be equal to fixture, right? And we're going to give it user.json. And we have a map, final t map will be equal to JSON and decode the tjson as data map. Right, so these should work. So this one would be a map string dynamic, and this one will be a raw JSON. We can go ahead in here and say, and start by acting, right? So because we've already arranged, so our action will be final result will be user model from map. What map are we giving to it? We're taking the t map, right? T map, and we're going to expect that the result equals the t model, the test model. So we want to make sure that it's equal to the test model, which is actually going to fail, right? So when this is what we're saying essentially, do get me a user model from the map that we've given to you, this map, right? This map right here, right? And when you get that, expect that its result is equal to this model over here. But then remember that this model's values, it has created that to be empty, created that, it has empty name to be that, empty avatar, the rest of them, right? So when we actually run that test, it's going to fail. Let's go ahead and run that, because they're different, right? No, I think I've run the wrong test. Blah, blah, blah. No. No, it's actually going to pass. I'm so sorry. The reason why it's going to pass is because over here, we're only using the ID, right? So let's go ahead and use everything else. So the name and the avatar. Yeah, so all of them must be the same. So remember, the reason why it was passing is because over here we have in the empty, we have 1. And also in the fixture, we have 1 as the ID. So when their IDs were the same, it was passing. The test was passing, even though it was in the same thingy. So for that reason, we're going to change that, and we want to make sure so we can see that the first one passed, this one, but this one isn't passing because they're not the same. Because the name is actually Lucille Dooley. We've got Lucille Dooley, and we've got empty avatar, and over here we've got some avatar from Cloudflare. I don't know. I don't want to open that up. I don't know what's in there. Might be Santa. So we go into equals, and we now try to change this. So it means that our JSON, we're not going to give it these generic things. We're actually just going to go into our user model. Where is it? User model. Copy these over. Empty creator that. Empty creator that. That's a long one, mate. This one's going to be empty avatar. And you, my friend, are going to be empty ID. So for the creator that, I'm actually going to leave the empty creator that as that. Sorry. Control Z. Copy. The ID will be 1 because in our user model we've got 1 for the ID. So I'm going to close that out right about. So inside of our test, this test is actually still going to fail because over here we've got this date. Then inside of our user model, we've got a weird date. We've got empty dates, empty creator that. We don't want that. So we're actually going to, what do we do? What do we do? Should we copy this over? Let's just copy that over. Let's copy this one over as well. Boom. Paste. Paste. And that's done. So let's go ahead and run the test again. It should pass this time because everything's the same basically. No, there's a problem. Empty name, empty avatar. So, oh my day. So this is the problem, right? The order. So when we call a from map, we're actually expecting that. Let's go ahead and see. So the name, what is this one? What's that one? The ID, the name, and the avatar. So the name for my expected, in this case, the expected is this. The expected is this one, this, and the result is this one. So basically, my name was my name was rather created that. So let me go ahead and change that. Yeah, it should be name rather. So the name is name. So we want to make sure that whatever we receive from the server is going to be the same as what we have in the model after we're done. So this is essentially what we've done. We've got the data from the server, and this is the data we get from the server, right? And we're simply saying, create me a user model from that map that we got from the server, right? And expect that it will be the same as do you know what? Let's just go ahead and create a user model from that. So we can say that we expect it will be the same as this, as the data from the server. Right, this is what we're doing. The reason why I was trying so much to match the data on the server with the user model's empty data was because I didn't want to have to create a user model in the equals in order to get it to match. I just wanted to have one T model and make sure that they match, like whatever data we get there matches this. So I don't have to create this to match, create a new one to have to match the server's stuff, right? So this way we just have one generic D model and we just make sure that the server's data is equal to that. And when we call the equals expectation, right, the result will turn out to be equal to the T model because in our user, we've actually created an equal. And we've actually overridden the Boolean operator, in this case, using the ID, the name, and the avatar. Right, so when we do that, we're expecting that the user model that we've got over here will simply be equal to whatever we have in the result that we got from here. I don't know if you understood that, but I hope you do. Group. Let's go to the next group. The next group will simply be the to map. No, the from JSON rather. We're essentially going to do the same thing, so I'm just going to copy this over because I'm lazy. Return a user model with the right data, and this time it's going to be the from JSON, and it's going to be tJSON. We run that. Once again, we pass the tests because it works, because we're expecting that the results we get from this will take the JSON that we've got over here and create a user model from it, right? Right, it will create a user model by taking its avatar ID created that name and giving them to these. And then finally we check if the thing that it created is equal to the empty one, right? And it will work because in our server, we're making sure we're hijacking the server response here and making sure that it's actually the same as the other thingy. So again, I hope you understand that. Let's move on to map. So we have the group to map, and for this one we're going to say final results will be equal to dmodel.toMap, and we can expect that the results equals our tmap because the user model's empty. The T model is actually empty, and the tmap, we're expecting that when we call toMap for it, it will simply match exactly what we have in the test map from the server. In this case, which will be this. Where is it? The user.json. Because we've actually made sure that it's the same thing. But this test is going to fail. Watch how it fails. Search. Yes. So this test is failing because... Oh, sorry. What's the problem? Go ahead and run. So this test is failing because what is the problem? It failed to load user model test instance of an outside test exception. Oh, we haven't put this in a proper test. I'm so sorry. I was expecting this to fail, but not that sort of failure. Return a map with the right data. Yeah, so once again, this is going to fail, right? Let's see. It does not fail. Really? Are your maps equal? Let's go ahead and see if the maps are equal. I was actually thinking the maps weren't equal. Whereas the user models map, it's going to be ID avatar created at name. ID. So the reason why I thought that was going to fail was before, when I wrote tests like this, the map equality, so checking if the maps were equal, would fail if the order of the keys and the values of the order of the entries were different than the order in the other operand. So in this case, we have two. We have this two map, the map from this, and the map that we derived from this. It usually was failing whenever they had a different order. So if ID came first in here, and in the two map ID came last, then they wouldn't work, right? It would usually failed for me. So somehow it's working. I think Dart fixed it. They fixed the map equality. So let's go ahead and also do one for 2JSON. Let's be happy. 2JSON. Should we just copy this one over? 2JSON will basically do the same thing, but we just copy that over. No, copy the entire test. Should return a JSON string with the right data to JSON. And then this one, the result will be equal to the 2JSON. Let's go ahead and run that test. It should pass. And there we go. There's a failure. It expected creator that. So you see what I mean? So it wanted. So in this case, yeah. So this was where it used to fail in the 2JSON section. So because it wanted their order to be the same. So if ID came first, it expected ID to be first in this one. In this case, it's different because ID was created at. Right, so let's go ahead and change that. Let's make sure that we follow the server model. So the two map model. So it's ID avatar created at a name. ID avatar created at a name. So let's go ahead and run that once again. And let's see. So this time they fixed the map quality. And now we're struggling with this one, with the JSON equality. So ID avatar created that. Finally name. So what's the problem here? Different at offset 1. Really? Really? What's the problem? What's the problem? Equals tjson. Let's go ahead and see. So the tjson will simply encode the map. What is your problem if it has next lines? So the expected actually had next lines. The expected is this one, a tjson. Yeah, that's not working. So let's go ahead and just create our own JSON over here. So let's go ahead and I'm going to copy this over. Right. Go over here. final tjson will be equal to JSON encodes this object. So that way you can get your new lines. So we can expect that it's equal to tjson. Let's hope that works. Let's hope that works. And now it works because it wanted new lines. Dart, you're asking too much of me. So no, that's not all. That's not all. Why am I closing up my file? Let's go over to copy with. So now we've done 1, 2, 3, 4, 5 tests. Group copy with. Copy with is going to have an arrange. I don't think we need to arrange anything, do we? We've already got a T model. So now we're just going to skip that and go to act. T model final result is equal to T model dot copy with. Right, what are we copying with? Let's change the name to Paul. So we're going to expect that the results dot name equals Paul. Or you could even add another expect. We also want to expect that. Oh my days, what's the problem with you? Yeah, whatever. Because I was typing when the test was running, so it's gonna fail. It's gonna fail me. Fail to load outside of a test. I'm so sorry. I keep forgetting about this. Test should return a user model with different data. I'm going to paste that. We're going to expect that's the case. And then finally, we're also going to expect that the results are not equal to. Alright, do you know what? Let's expect that the result no. I have an issue with my test. Failed to load compilation failed for this person. Why would your compilation fail? Expected. Have I made any grave errors? No, I haven't. I don't think I have. Have I? Why would you do that to me? What is the problem? .js utils. Have I imported some? Oh, I've imported something crazy. .javascript library. Alright, so that's it for the model test. Right, so next up, we're going to create our repository implementation. Let's see how that goes. So now in order to create the repository implementation, we are still in the data layer. I'm going to go into the data layer, create a new Dart file, and I'm going to call that the name of our previous repository. Right, so the previous repository in the domain layer was authentication repository. So in here, I'm going to call that one authentication repository implementation. Right, so this one is a contract that defines that every time we want to create a user, we need the creator that, the name, the avatar, and we will always return a future either failure or a void. Right, and this one, whenever we need to get users, we always never take anything in the signature, no argument, right? But then we always return a list of users, right? So this is what we're doing. Now we have to write the implementation of that. So you can see these contracts don't have a body. There's no body in here. It just defines how this should work, how it should look, basically. Sorry, I messed that up. Yes. So that is how that works. Now let me close up these tests. Now the implementation thereof would be a class with the name repository implementation, right? And it will implement the authentication authentication repository, this one. Now in here you can see that it's asking for override. So we've written the contract. Now inside of the implementation we have to override the interface. The interface that we've created, we have to use, here we go, we have to use polymorphism. I think that's what we're using. We have to use polymorphism and change the behavior of the parent, or we could leave it that way, but we're not leaving it that way because the parent is simply an interface. It doesn't have any functionality to it. So we are going to implement the functionality of the functions. Now, as I already told you, we're basically going to be following the principle D, dependency inversion. Dependency inversion isn't anything scary. It's simply this. So in here, we actually need to talk to the server. When we're creating a user, we need to do maybe http.get request to the server, and then we get the response. Final response will be equal to that, and we can then return JSON decode the response or whatever. This is how the HTTP requests work normally. I know you should have already done some API stuff, right? You should already be familiar with consuming APIs at this point, right? But we're not going to be doing that in here because that is not the function of the repository implementation. The function of the repository implementation is to talk to the data source, right? So the data source will then talk to the external HTTP library or whatever external service we're using, and then it returns that response down to this person. This person in turn takes it back to whoever's calling the repository. So for that to happen, we will need a data source, right? So our data source will be equal to something, data source. So let's go ahead and create that data source. Data, new. Oh, sorry, I created this in here. We have to create a new folder for this. Call it rep. I usually call them repos, but since it's the tutorial, let me make it full repositories. We push that in there. Then we finally create a new one, new data file, where I'm going to put that in the data sources. It's going to be the authentication remote data source. So it's a remote data source because it's talking to the remote server. If it was speaking to the local server, like the cache on the user's device, then we would say something like local data source. But in this case, it's remote because it's talking to the remote server outside. Now, for this one, we also will create an interface before actually implementing it. So let's go ahead and do that. So we are creating a lot of interfaces. By the end of this lesson, you should be familiar with creating these interfaces. So I'm going to call that authentication remote data source. And I'm going to invoke that abstract class. Then we have our, now remember that in our repository, this one, we were using this functionality where this functional programming functionality where we're either returning a failure or a void. However, in the remote data source, you will only be returning one value, right? So if an error occurs inside of your data source, you throw the error, you throw a custom error. You can throw the error you already have, but for industry standard code, it's best practice to create your own error, your own exception, and then throw that exception because it helps you define, helps you have more control over the message that you're putting out down to the other layers. So basically what I'm saying is inside of the remote data source, we do not do either failure or. When there's an error, we will throw that error. If there's no error, we will return the actual value. Now, when there's an error inside of the repository will catch the error that we've thrown and then return either a failure or the value. So if there was an exception thrown from the remote data source, this person will catch that and then return a failure rather. But if there was no exception thrown, then it will rather return the actual value. So in here, we're not going to do the either or. So what do we have? We have the create user, which takes these three. So we can do that. Create user. Now it takes these three. Let's go ahead and put that there. Now remember that this is a contract because it's an abstract class. It's an interface, right? So we don't need to create a body for it. What does the create user return? It returns either failure or void. In our case, we're returning a void. If there's an issue, we will throw an exception. Let's go ahead and do the same for this person. So we have get users. So for this time, future get users. And it doesn't take any params. So there's no parameters, but there's no parameters, but there's a return type, and the return type is a list of user. Now, instead of doing list of user, we want to do list of user model. This was my model. I think my computer froze. Oh my. So we want a user model. So this is the catch. In every other layer, we're going to be talking about the core entity. We're talking about the entity. But then in the actual data source, when we get that value, whenever we're returning something, we want to return the model version of it, because later on we're going to be using values like serialization from JSON to JSON. We're going to be using copy width because our classes are basically final, right? These are final. They can't change. So we need a way to mutate their values, and that is where copy width comes in. So we need these values. We will need these values further down in our UIs when we're changing stuff, when we're sending stuff around. So for that reason, we will need to always remember in your remote data sources, you don't return the entities, you return the models. This is how it works. However, in the other layers, you do not explicitly state the model. You state the entity. Why is this? Why are we doing this? Why don't we just do, where is it? Why don't we just do list user models, since we know we're going to be returning user models along the line? This is because we want it to be as loose as possible, so that if there's another class that implements user, imagine that if we had a different type of user, an admin or something, so inside of user, we had also class admin extends user. Imagine we had that. If we made it to be, if we came here in our remote data source and we made this to be user, if a person was an admin, after we logged in and the server told us they're an admin, how then would you tell your application that this time it's going to be either a user or an admin? That doesn't make any sense. That That is bad practice, right? So because we want it to be as loose as possible, we want, this is also another principle of solid, right? We want it to be basically implementable by anything. So every single interface or every single entity should be able to be subclassed. So we want it to be so open that we can take any class at all, any other subclass of it, and replace this version of it with that subclass. So if we had to return an admin, we can return an admin. If we had to return a normal user, we can return a normal user. So that way we always, in the other layers, always make sure that we're taking the generic entity instead of the actual model implementation of it. So let's go ahead and leave this way. Let's leave this way for now. Now, for our remote implementation or repository implementation, we will simply come over here, create our authentication remote data source. This is how it's simply going to work. We create that data source, and we remember that our data source is going to be throwing exceptions at us when there's a problem. So we will take the data source dot create user, and we pass in these things in there, and then we do stuff with the result. We return it here. If there's an exception, we handle it as well. Now, that's all great and well, but remember, I'm trying to explain what dependency inversion is. Dependency inversion is simply what we do when we take the dependency in the constructor. It simply means that we're creating a space for injection to occur. If we wanted to inject something into this class and there's no space for us to inject something into it, then there's no way for that injection to happen. But if we wanted to create a space for injection, we do that through the constructor. So whenever you take something from the constructor, for example, a remote data source, which is a dependency of this class, because we know that this person will need a final data source, and then it will use that data source to call create user. This person will also need that data source. Instead of creating that multiple times, we simply inject it into the class. So that way, we can use it without having to instantiate it multiple times, and also it helps us when we're testing, so it makes our class testable. You might have heard it a lot of times. You write testable code. What does it mean to write testable code? This is part of what it means to write testable code. This is a major part of it. If you don't inject your dependencies, then when you're writing a test for this class, how do you control? Remember what testing does. When we ask 3 questions, and those 3 questions, part of it is, how do we control what our mock? How do you even start mocking your dependency after you create a mock of your dependency? For example, a remote data source. Imagine that we're not taking it in the constructor, and we have our final data source in here equal to, and it calls create user, and we also have another final data source in here. And then finally, in our test, when we're creating our test, we create that mock data source, extends whatever. After doing that, how then, when we're testing these functions, are we going to pass in that mock version into this? How are we going to do that? You can't do that. So in order to make your code testable, we need to make it so that our class is injectable, so that we can inject our mock dependencies into the class. This is the entire reason why we're using a dependency inversion. So dependency inversion is simply, instead of taking this dependency in here, we invert it and inject it into the class directly. So in here we do this dot remote data source, and I prefer to make all of my dependencies private. So that way, because dependencies are meant to be dependencies for the particular unit, right? We don't, remember principle S, single responsibility principle. We don't want other classes or other units to control or control whatever happens inside of this place, except we're in a test. So we don't want other people to be able to control what the remote data source inside of this class does. So we're going to make that private. We're going to take that in the constructor remote data source, and that's it. So in here we will be using that remote data source that we've injected, and we will use it to carry out our functionalities in the method. Now, the principle of TDD. Remember, the course is about clean architecture, the principles of solid, and the principles of TDD. The principles of test-driven development. Test-driven development. Oh, sorry, my fonts is low again. Not plugin settings. Fonts. I've got to put that to 16. Alright. Yes. So, I hope you can see that better now. I'm so sorry for not putting it up earlier. The principle of test-driven development. Test-driven. It's driven by tests. So we are going to be writing our tests first before we actually implement the functionality. So in order to write the test first, we need to know what we want our method to do. So we're going to be writing the test for the create user method before we actually implement that method, before we write the code that will do that. So we want to be able to know what we want our class to do. What do we want the method, rather, not the class, the method create user to do? We want create user to, first of all, we want it to call the remote data source. So you break it down. This is usually, you can actually follow these testing principles for all of your repository implementations. This would work across the board. This is why clean architecture is so beautiful. The moment you learn how each module works. For example, this module, right? How this module works and how the test is written. The process that it goes into creating the test for this module. You no longer have to learn a different way to write tests for it. It's simply, you're just going to be writing tests the same way for every repository implementation. You're going to be writing tests the same way for every remote data source. You're going to be writing tests the same way for every module, every use case, and so forth. So how do repository implementation tests work? First of all, you test to make sure that we are calling the dependency, in this case the remote data source. If you have a different dependency, you would also write a test to make sure that you're calling that dependency. Secondly, you check if the method returns the proper data. What does that entail? Let's go deeper into that. So we're on the small, so this is on the larger scale. This is what we're checking, if the method returns the proper data. So, but then what does that actually mean? On a smaller, when I break it down, what does that actually mean? We're testing to check if when the remote data source throws an exception, we return a failure, and if it doesn't throw an exception, we return the actual expected data. This is what we're doing for the test. Let's go ahead and write our test. So where is my repository implementation? There, new .test file, authentication, repository implementation. Now, for this, what is our dependency? Remember, what we need to know our dependency. First of all, our dependency is going to be the mock auth repo. I'm just going to I actually prefer to shorten this because I don't know, it's going to be very long if I write out that entire authentication repository implementation. Personally, I just shorten it. You can leave it as long as you want. So class mock auth repo implementation extends mock from the mock tail, implement the authentication repository. That is really long. So you can see why I prefer to shorten that. And then finally, we have our dependency mocked and ready to be manipulated. So let's go ahead and create our void main, the entry point for our tests. So this is where our tests will start. Let's go ahead and do the setup. So for our setup, for each test, we actually want to create, we actually want to create a new, repo implementation, which will be whatever. So let's create that here. A late authentication. No, sorry about that. Our dependency is not the repository implementation. Our repository is rather the authentication remote data source. I'm so sorry. That is our dependency, not the other thing. So it's rather the mock auth remote data source. I'm going to write src for that source. This is a bad practice. You probably want to do that, but don't care. It's not a real project. Authentication. So my late authentication remote data source. Notice how I'm not writing the mock over here and just telling this right away that it's mock. I just prefer to write the actual class, right, so that we know what I'm looking for. And then when I'm creating it in the setup, I rather replace the instance with the mock version of it. So we're looking for the remote data source. We also need our late authentication repository implementation. That's a long name. Repo implementation. For this, we're going to call the authentication repository implementation the real version of it, right? Because we're not going to be manipulating or pulling any actual sources in here, so we don't want to mock it. We only mock our dependencies. So in this mock, I'm just going to remove this. It's going to use this one. Then before I actually instantiate this one, I'm gonna create the dependency so that by the time that this gets created, as you can see, the local variable is definitely unassigned at this point, so that by the time we create this will be assigned. So let's go ahead and do that before data source will be equal to the mock auth remote data source. And that's it. We're done with our setup. Now, how does this test actually work? Remember, I told you that we're going to test the functions one after another. So first function we're going to test will be the create user. So remember that inside of the create user, we're going to be testing for two things. First of all, to check if it calls the remote data source. Secondly, and to make sure that if... So we could do this in two different tests. We could also make sure that it returns the proper data if there is no exception. So these are the things we're going to be doing. Make sure that it calls the remote data source. We're also going to make sure that it returns the proper data if there's no exception. This is basically a sub of this. So this is the broader term. We can put this in here. Also check that when it throws an exception, return a failure. And if it doesn't throw an exception, return the actual expected data that was fulfilled over here. So we first of all make sure that it returns the proper data if there's no exception, but then check if there's an exception, right? And then we return a failure if there was an exception. So these are the three things we're going to be doing. But then sometimes I prefer to join this into this. We can put that into one test, and you're going to see how I'm going to do that, so that we don't have too many tests. But then first of all, we have a function, a method to test. So for each method, you want to create a group. Sorry, I'm outside of the void main. I have to be inside the void main. So we want to create a group. This is a group. A group just simply is a group of tests. We're going to be writing more than one test, so we want to put that in a group. We're going to be writing more than one test for a single functionality. So that's why we put in a group. So what functionality are we writing the multiple tests for? It's the create user. You write the name of the function the way it appears. Where is our repository implementation? This is it. So we write that way. We close this out and we go ahead and say and start with our test. So the first test will be a test. The description, remember, what are we trying to do? We're trying to, make sure that it calls the remote data source. And remember, I wanted to join this into it as well. So should call the remote data, the remote data source dot create user and return the proper data. In this case, we're not returning anything because create user is returning void. So let's, instead of returning and complete successfully when the call is successful, when the call to the remote source is successful. Let me go ahead and cut that bit. That is super long. Let's go ahead and do that. That should solve that. Asynchronous function. Now we start writing our test. So we want to make sure that we call the remote data source and we want to make sure that it completes successfully when the call to remote source is successful. How are we going to do that? So if we want to make sure that the create user got called, right, we want to use the verify. We verify that the remote data source dot create user got called with what values? With whatever values that we pass. We want to make sure that it got called with the correct data as well. So we're checking for three things inside of this function. Check that remote sources create user gets called and with the right data. So and then we make sure that it got called successfully. So in order to, well, this will actually tell us if it got called. Then passing in these will tell us if it got called with the right data. And how do we know that the data is the right data? We know that because whenever we call the remote data source, we're calling it from the repository implementation. The repository implementation would take these data and pass it to this person. So meaning that in order to make sure that this gets called with the right data, we just want to make sure that whatever data is here matches whatever data that was given to the repository implementation. So this is the assert part. Now we have two parts. We have arrange. I just started with assert because I don't want to confuse you. If I started from, I just want to start from doing this and show you how or why we need arrangements, right? So now I'm going to take care of these later. So this will actually take care of that. We also want to make sure that it got called once, right? We want to make sure that it got called once. Now this will take care of this part. Now we also want to make sure that it completed successfully when the call to remote source is successful. So in here, in our arrange part, when the remote data source dot create user gets called with any named created at any named name named so once the remote data source gets called with any of these values, we don't need to mock the values because these are strings. They're Dart types. They're native Dart types. I don't think we need to mock them. We don't need to. So anytime this function, this method, Command L, Yes, so anytime that method gets called with any value at all, anytime this method gets called, this is basically what we're saying. Dot then answer, we're using answer because it's a future. Then answer with your invocation, which we don't need. We need this to be async. Always remember for this to be async. Always answer with a right. A right. Right means no. The remote source doesn't return right or left. It just returns void. So always return with the proper void value. So we can't return void. Dart will not let us do that. So whenever you're returning void, you should use future.value instead. So anytime that this gets called, always return a future value. Always return the correct data. Don't throw any exceptions, because in this case we're testing to see if it returns the right value when it's successful. So this is also where dependency injection comes in handy, right? So because our dependency, we can manipulate the dependency and make sure that when we're testing for success, that it's always successful. So this is what dependency inversion does for us. This is where it's beautiful. Now we have hijacked the return type, the return value, or the functionality of dependency, and we're saying whenever you get called, always return success. Now we're also checking to see that whenever there's success, we also want to make sure that the function, the actual repository implementation that we're calling, the create user over here, completes successfully. And how do we do that? First of all, we act. So we act and we say the final results will be equal to, we can say it's equal to await for the repository implementation dot create user with some values, right? We can come back to that later. We wait for that to complete, and then we expect that the results is equal to, so remember that whenever the create user gets called and it returns successfully, right, we always want this to complete successfully. And how does it complete successfully? It will return a right value, because this is either failure or void, and the void is always on the right, so we always wanted to return a right hand user. This might be a lot to take in. If you're confused, go back in the video and start from whatever you got lost at. But then we're just going to make sure, expect that the result will always be a right. A right what? A right in this case is going to be null. Why is it null? Because it's void. And we can't say a right void. So whenever there's a void, your right hand type will always have a null value inside of it. So we can check this and say equals, that the result is equal to a constant right hand type, and that's it. So this makes sure that whenever this completes successfully, which we're forcing it to complete successfully, that it will always return a right hand type. Now back to this. How do we make sure that we get the proper data from the repository implementation? We simply create these. We create these, and then we make sure that those values that we passed in here are the same values that reflect in here. Right, so this is basically what we're saying. We're saying that our final created at will be equal to, I don't know, whatever you want to call that. Whatever. Now, what have we got here? Const, copy that, paste. Now, essentially what we're saying is call the create user and give it created at, this name, and this avatar. Now, when we're verifying to make sure that the create user got called. 1. 2, we're verifying to make sure that it got called with the same values that we're here. So if let me go ahead. So if when we're calling the remote data source.create user from the repository implementation, yeah, if when we're doing that, we're passing the wrong value instead of passing in the actual value that was from the repo implementation, then this test will fail. And then finally, we want to verify no more interactions with our remote data source. We want to make sure that nothing invokes remote data source again after we use it. So you will understand this a little better when we start writing the implementation. Now we're in the phase 1 of our test, which is what? The red phase, which is where your test will fail because you haven't actually implemented it. So this is our test. This is what we want to make sure. We want to make sure that this is the case. How do we make sure that that's the case? We can see it's failing because it's unimplemented error. We haven't implemented it yet. So we can go ahead in here, and what is the test that we just wrote? The test that we just wrote is trying to make sure that 1, we call the remote data source. And how are we going to do that? Fine, we're simply going to do await, right? Sorry, await remote data source, which is the whatever remote data source that got passed in here. Remember, and now it's important because in our test, in our test, we've passed in a mock version of that remote data source. So we're basically using this data source that we're controlling. So over here, we're controlling its return type. So in here, whatever data source, when we're actually using this class in our actual application, we're going to be passing in a different remote data source that we've created, not a mock version. So, but then even in this case, look how beautiful this is. In this case, we're passing in a mock version that we're going to be controlling its functionalities. So even whenever this class is running in a test, or whether it's running in an actual instance of the application, it will still work in both cases because it's taking that instance in its constructor. So we can go ahead and say that to make sure that we're calling the remote data source, in order to make sure that that particular test is passing, we're going to do remote data source.create user, right? And also in order to make sure that the test where we're checking to verify that it gets called with the right data, we're going to pass in the actual data that we have in here. So now this will actually, so for now I'm going to return just a right null, just for this function to stop screaming at me. So now the first test is going to pass, right? We're trying to make sure that this part, the verified part, works. So I'm going to go back and rerun the test. So let's go ahead and run the test. You can just run the group if you wanted to, but I'm just going to run the entire thing. So let's see if this test passes. So we can see that the test has passed, right? But then imagine that inside of this place I made a mistake, and instead of passing in the creator that I had over there, I passed in a different creator that. So just a random different creator that. Remember that the actual creator that we're passing in is this, whatever creator that. This is what we're calling, and we're passing it in there. So in here, when we receive this, I'm going to pass in the wrong one. You can see that the test will fail. So if you make such errors, the test will alert you. It will fail, and that failure will alert you. Right, so no matching calls. There was no matching calls because we have a different creator that. Meanwhile, in our actual test, we're passing in whatever .creator that, not a different creator that. However, in this case, this will pass. And now we also want to make sure that the return type is correct. So we want to make sure that we return the results, whatever result we get from this. So this person actually doesn't have a result. So we can either say final result or whatever. But since it's void, you can leave this way and always return a right null. Remember, I told you when your function returns void, in here you always want to return a null. So I'm going to make that constant, and the first test passes. Now, finally, remember we have a different test as well. So we've completed the test to make sure that it calls the remote data source. We've also completed to make sure that it returns the proper data, in this case a write null if there's no exception. Now, what if there's an exception? Let's go ahead and fake an exception. So inside of the same group, we create a different test. And this test should return a server failure, this time a failure, or a server failure rather. Let me just call the server failure when the call to the remote source is unsuccessful. Cut that, save that. Now we want to make sure that whenever a call to the remote source is unsuccessful, that the implementation of our repository returns a left server failure. You could actually make that left rather server failure, but I just prefer to write the actual return type of the left or right. So we have async. Now we're actually gonna mock or stub. This is called stubbing. Remember, we're actually gonna stub the hijack the remote data source. So now we're saying that whenever the remote data source .create user gets called with any of these, let me copy the arguments. Remote data source .create user, whenever it gets called with any of these, paste, then throw, what am I doing wrong? Then throw, what are we throwing? So we're going to be throwing, in this case, a server exception. I haven't explained this bit to you yet, but so for now we have failures. In our data sources, when we catch an exception, remember I told you we don't want to throw the raw exception. We want to convert it into our own defined user-defined exception. So we're going to be defining our own exceptions, which is going to be an implementation of the actual Flutter or Dart exception. So we're going to be throwing, in this case, a server exception. I haven't explained this bit to you yet, but so for now we have failures. In our data sources, when we catch an exception, remember I told you we don't want to throw the raw exception. We want to convert it into our own defined user-defined exception. So we're going to be defining our own exceptions, which is going to be an implementation of the actual Flutter or Dart exception. So we have inside of errors, we have exceptions. And in here, we're going to have the class server exception. If we also were talking to the cache, we would have class cache exception. But in this case, we're not talking to the cache, so we're going to have a server exception, which will implement, or let's make it extend equatable, because we want to be able to equate if an exception is the same as another exception. So we extend equatable, and then we implement the raw Dart exception. And in here we have server exception. In here we will take fired this dot message, fired this dot status code, because the raw exception doesn't tell us the status code, but in our case we want to have the ability to tell the status code. This is also part of why we're creating our own exception. So whenever the server returns an error, we also pass in even the status code. We can take final string message, final integer status code, and we can override the, let me just, don't want to type that by hand. We can override this and tell it that for this class to be equal to another class, both of their messages and their status codes should be the same. So now inside of here, we're saying that whenever the remote data source gets called, we want to throw a server exception. And this server exception is going to have a message that's going to say unknown error occurred, and it's going to have a status code of 500 because it's from the server, so it's going to be an integer rather. Let's go ahead and save that much constant, add a comma, so now we're saying that whenever someone calls the create user for this test only, throw an exception. Now, how do we expect our actual implementation to handle it? This is the arrange. Now we go ahead and we act. How are we going to act? We await. Well, let's save that to a result because it will return a left something. So we await for our repo implementation .create user to be called. So we actually want to call it with these same values. So I'm just going to move these up into this place. So that way everyone can have access to it instead of only that first test. So we wait and we call. So we're acting. We're calling this and we're expecting that whenever that happens, that the results that the repository implementation will give us will be equal to a left this time, and it will be equal to a left server failure, and that server failure must have the same message. Sorry. Don't we have a server failure yet? Oh, we have an API failure rather. So because we're using an API, not a server. So over here we can also change this to be API exception. Refactor. We have an API failure and we have a message, and that message must also be the message from this person. So unknown error occurred. And we also have a status code 500. Boom, boom, boom. Pop. Oh my, that's ugly. Add a constant. Save this much. Add a comma. Save that much. Yeah, that looks better. So we're expecting that whenever this person throws an API exception, that in our actual repository, when we get an exception, what do? We return a left API failure using the same message from that exception. If you want to understand this better, we could save this exception. So we could just save this exception up here. Say final test exception. The T means test will be equal to this exception. We can make it a constant because it's got a constant constructor. We can just simply then throw that exception, T exception. So we want to make sure that our failure is using the same message from the exception so that our user sees the same message that came from the exception. And we also have T exception. There we go. Dot status code. And over here we use the dot message. We can remove the constant because it's no longer constant. We can add the commas, format that. So now, after doing that, we actually want to verify that the remote data source, regardless of the error, we want to make sure that the remote data source.create user got called and it got called with the correct data. And it also got called once. Then we verify that there's no more interactions with the remote data source after the error occurs. Boom. We've got our tests and we're still in the red phase. So let's go ahead and run the tests. We can see that the first test will pass. The second one fails woefully. There you go. So the first test passes, but the second one fails because an unknown error occurs and we don't return a left failure. You can see it's throwing that error right back at us. So how are we going to handle that error? Because it's an unknown exception, it hasn't been handled. In order to do that, we will simply wrap this in a try-catch block. So we do this, else on API exception, we can catch the E. So in this case, we don't need to catch every exception, right? Because whatever exception occurs, no matter what sort of exception it is, whatever exception occurs in the remote data source, it will always return an API exception if it was talking to the server. If it wasn't, it will always return a cache exception if it was talking to the cache, and so on. Whatever it was talking to, we will create a custom exception for that. And in our remote implementations, we know what we're talking to, so we can expect or watch for the exception from that provider. So in this case, our provider is the API because we're creating a user. On API exception, we will simply return a left server failure, API failure rather. I'm so used to server failures because I rarely use APIs. And the message will be e.message and the status code will be e.status code. Easy peasy, lemon squeezy, and that's it. Now our test should pass because we're catching that error and we're returning an API failure that uses the same message and the same status code. Let's see, and we can see our test passing. Now, in order to make this a lot more succinct and shorter, we don't want to always have to do this because we're going to be doing this a lot in a lot of places. I'm telling you, it's going to get a lot. So we always want to find ways to make these things shorter. So I'm going to create a different constructor in here. Constant API failure dot from exception. We can say dot from API exception, but nah. Get it. I'm just going to do dot from exception. And we're going to take an API exception. Let me also rename this to API failure with capitals. So we have harmony. So this is our exception. And with this, we can actually make this a factory constructor. Or we can do, but today I'm not teaching about constructors, so I'm just going to go ahead and use this constructor and return this with the message, where the message will be exception.message and its status code will be exception.status code, and that's it. So it's not a constant. Let's go ahead and save that much. So in our repository implementation, we can simply return a left API failure dot from exception. We can pass in the E as the exception. And our test, every time you change something, always rerun your test to make sure that nothing broke. There, our test passed. So now you can pause the video and try to write a test for the get users. Go ahead and pause the video. Alright, so if you were able to do that, then well done. If you weren't able to do that, don't worry. This one's a little bit different because we're returning something and we're not taking anything here. So let's go ahead and delete this. No, I'm not deleting that. Remember, we always write the test first before the actual implementation. So let's go to the test file. I'm going to close everything. Close tabs to the right. Yes. And then I'm done with this group. I'm going to create a different group. Group get users. I hope that's what it's called. Yes, get users. So the first test, similar to our first test, we can just simply come here and see the first test should call the remote data source create user and complete successfully when the call to remote source is successful. In this case, we're going to do something a little bit different. Should call the remote, what was it? Remote data source dot get users and return a list of users when call to remote source is successful. I'm gonna go ahead and cut that. Oh, sorry. Yeah, that's it. I officially can't type. So we take this away. There you go. Now we hijack the president. There you go, Mr. President. Remote data sources are president today, and when we get users, remember we're not taking any params. So there's no parameters, so we can go ahead and say dot then answers with the invocation that we always almost never need. And it's going to be, I'm sorry, async. What are we returning? We're returning a fake list of users. You can go ahead and create a fake list of users in here with users.empty if you wanted to. User.empty and create more and more if you wanted to, but I'm not going to do that. I'm just simply going to return an empty list. Remember, the remote data source.getUsers will return a direct list of user model. So now you can write a test to make sure that this gets called. Let's format that. So final results will be equal to await for the repository implementation dot get users, and we want to make sure expect results equals constant write null, not null this time, a write empty list, and we also want to verify that the remote data source dot get users got called, and it got called once, and it didn't get called with anything in its signature. And we also want to verify that there's no more interactions with the remote data source. Ooh, that was a long test. So now let's go ahead and run this test. There will be a few problems with this particular test. So let's start from the first one, unimplemented error. Let's see, go. Come on. Yes, there we go. Unimplemented error. Let's go ahead and implement that. So first of all, we want to make sure that remember, you don't always want to write the full implementation. You want to write as you test. So this time, our test is only asking, so you want to write as much as will make your test pass. What is going to make our test pass in this case? The only thing that's going to make our test pass is if we return exactly the list that was returned from the remote data source when there was success. And we also want to test to make sure that it got called with the right data. So we're just basically going to be doing one thing, basically. Final result will be equal to await remote data source dot get users, and we return a right results. So tell me, is it going to pass? Fail. So now you can see, what is the problem? The problem is that we're expecting, right, a right list of users, and it returned actually a right empty list as we asked it to. This is the actual problem with lists in Dart. Lists are difficult to equate. They don't have proper equality. They don't have value equality. If I can use that. think that's what it's called. So in order to actually write these sort of tests in your repository implementation, where you have a return type of a list, whether you put something in here or not, this test is going to fail. Even if we put in the same value in here and there, it's going to fail. In order to test that, what I usually do is, instead of checking if it's equal to an empty list, right, I rather check if the result is A. If it is a right, what is its type? On the right hand side, on the left hand side, it's a failure. You can put in failure, or you can just put in dynamic, like I already taught you. So we want to make sure that it's a right dynamic with what on the right hand side, it's a list of user. Right, so that's it. So this test should pass. Now you might ask, how then do we know if the values of the tests of the list are the same as what was returned? What is the problem this time? Matcher is a right list user. Oh, I forgot to close this. So is a should be invoked. So that's how I usually pass this test. You can see it's passed. Let's go ahead and write the second test, which will be testing when there's a failure. So test. I'm thinking about just copying this over, but where is it? This one. This one should rather be an API failure. So it should return an API failure when the call to remote source is unsuccessful. Let's go ahead and copy that. And then we return that function. And we can check to make sure that when remote data source dot get users dot then throw an exception, an API exception. Now we already created one, so T exception, and we can act rather. Final result will be await repository implementation dot get users, and we can finally expect that our result equals a list. Sorry, not a left rather. Server fail, API failure. Dot from exception, T exception. We expect that it has the same message. We verify that remote data source. You can just copy these over. That should solve it. Nice. And we can run that test. And we can see we're back in the red phase. So let's go ahead and implement this and put it in the green phase. So let's go ahead and cut that and try catch. Boom, our test has failed. We're waiting for on API exception, catch the exception, and rather return a left API failure dot from exception with the E as our exception. We can go ahead and run the test again. Nice. So we're done testing and implementing the repository implementation. And then finally, for our external layers, we're going to write the test and implement the authentication remote data source. Now, what are we going to do for this one? Remember, this is an interface. We're not going to be testing the interface. We're only going to be testing the implementation. You could go ahead and create a different file for this, but I'm just going to put this in here. Usually we put this in the same place as the implementation for the remote data source. So I'm going to copy this over. Auth remote data source implementation. You can type that out in full station, or you can just make it impler. EMPL extends authentication remote data source. Oh, that's no, it implements because it's an implementation. It will implement implementation authentication. That is a long name. That's too long. I'm sorry, I can't do that. Auth remote data src impl. I'm so sorry. That's too long. I can't follow good coding practices in that case. It's too long. Boom. We make sure that we have asynchronous functions. Always asynchronous functions. And now we have these. We're in our red phase in our test. We haven't written the test yet, but when we write this test, we will be in our red phase because we haven't written any implementations. So now that you've learned how the repository implementation testing works, let's go ahead and learn the structure of a remote data source test. What do we do in a remote data source test? First of all, we check to make sure that it returns the right data when called to the client or to the dependency or whatever, or when called to the server, or when the response code is 200 or the proper response code. So the reason why I'm doing this is because sometimes, for example, for create users, we're going to be doing a post request. If you know anything about HTTP requests, post requests rather return a 201 conventionally, not a 200. So if you're only checking for 200 for your success, then when there's a 201, your app will rather throw an error, even though creating user was successful. So instead of considering only 201, make sure that you know what method you're calling. If it's a post request, check for 200s and 201s. I think delete has a different one as well. I think delete also has 201s inside of it. I'm not too sure. I don't remember. Or 204s. I don't remember. You can check them on Google, but I know that post requests have sometimes 200s and sometimes 201s. Some people make them 200s. I don't know why they do that, but normally it should be 201. So let's go ahead and no, I'm still teaching you the structure, so let's not write the test yet. So the second part is, so this is 1. For 2, we check to make sure that it rolls an exception, a custom exception with the right message when status code is the bad one. I guess I could call it a bad one. So look how similar the tests are. So for this one, we write a test to check when the remote source. Let me show you the test rather. We check to make sure that when a remote source is successful, we do this, and when the call to a remote source is unsuccessful, we do the other thing. But then in here, we're rather going to be doing the same thing, but on the upper level. So we're moving one step higher. Instead of checking on the remote source, we're checking on the response code. So the first one was when the call to the remote source is successful, do this or do that. When it's unsuccessful, do this or do that. In this case, for the remote source, when testing the actual remote source, you do this instead. You say when the response code or when the server's response, which is the same thing as the response code, right? Or you can say when the status code rather, when the status code is this, do this or that, and when the status code is that, do this or that. So let's go ahead and write the tests for these. Let's go into our remote data source and create a new .test file. That is a long name. I hope I don't mess it up. Authentication, yes, remote data source. Now, what is our dependency in this case? You can see that in here we've created the implementation. What does this implementation depend on? It will depend in this case on the HTTP library. So in that case, let's go ahead and add HTTP to our Flutter project. I'm going to do this, Flutter bulb add HTTP and Flutter bulb get. That should add me the HTTP library